So good morning also the colleagues on the WebEx. I hope you have a very nice evening yesterday in Cologne and others in their home. And without further delay, I'm gonna start to introduce our speaker. Please, the colleagues of the WebEx and everybody, the Slido, the same than yesterday, but please choose the right session. And now, again, without any delays, I'm going to introduce our speakers. So, Sebastian Pabias is the co-president of GUTMA, and he will present the outcome of GUTMA survey on the EU space regulatory framework implementation. So, I guess the survey was launched from your members, but also from others outside. But I guess you will
Yes, I'll explain it. I will explain it.
The floor is yours.
Thank you, Maria. Good morning, everybody, and thank you for having me here and the opportunity to present what GUTMA is doing in the domain of this. But first, I hope that you, as Maria said, rest well yesterday evening and you are ready for the next day after the very dense and intensive discussion yesterday. So GUTMA, I hope you already know GUTMA, Global UTM Association, was founded 2016, and we're already pushing forward towards the UTM implementation as embracing the different stakeholders who benefit from the UTM implementation. Okay, I was told to do this, yes. So GUTMA is working with the members and working on delivering the value to the members. And last year we developed the way that we setting up the task forces. Task forces is the idea that members team together. One member brings the idea what need to be discussed, and along the members we discussing the certain problem and creating the white paper or some solution which can be distributed afterwards publicly. So that's the way how the GUTMA operates today. So based on the feedback from our friends from Eurocontrol during the Amsterdam Drone Week, we've been asked to explain what is the UTM ecosystem readiness across the globe and what are the best practices which can be implemented in the central countries which didn't make any UTM implementation yet. So we started working together, and in July we kick off the task force. Where the objective was to collect the information and assess the maturity of the national UTM ecosystem around the world. Obviously, today I will touch the EU space implementation, but it's mainly addressing the whole world. So during the July and October, we work to prepare the survey questions and prepare the way how we address the certain problems and how afterwards we assess the results. And we prepared the survey, and in September we released it to the members and to the public. We received several feedbacks and several answers to the surveys, which gave us the perspective. However, we understood that that's not ended. So during the Harmonized Skies in November, our flagship event in Dallas, we will present the outcomes, but we will keep going with this survey afterwards. And we prepare like the annual ecosystem readiness, UTM ecosystem readiness reports. So we want to keep going and understand really how the industry develops and how the country implements the UTM to enable scalable operations, because that's the purpose. The next one. Yes. So methodology. As mentioned, the task force rely on the members, and each task force has a leader. And in this case, the PwC, our member, decided to be the leader of this task force. And I think this is really perfect match, because PwC has a big history and capabilities to make the consultation and also understand the market. And with their methodology, we created the 6 dimension pillars to address the problem and also understand the problem, and somehow based on this create the outcome which will be ready in the November during the Harmonized Skies event. So we set it in the 6th dimension, and the first one is legislation. So This question helped to understand what is the regulatory framework concerning US operations or UTM, which is very important. We touched it yesterday. We probably will talk today. In the Europe is the 664, 665. So that's the use-based regulation. In the other regions, they might be different one. But it's important to understand what is the framework which is implemented already today. Is it implemented, or is it only in some kind of planning phase? And the second one is the governance. So that's important aspect to understand how collaboration between the public and private stakeholders is set it. And it's not usually only about the UTM, but it's about the whole ecosystem. Because as we know, UTM is the enabler. UTM is this great table which allows us to build up something and build up services based on that. And the collaboration between the public and private is crucial here to make it happen at scale. The third one is a strategy. So as in any organization, we have to have a clear vision and objectives and approaches to support the specific solution. And if it's not set it properly, the implementation will never happen successfully. So we also assess the level of strategy readiness in the organization, but also in the country level. So if we have the right strategy in the country level, we can really execute it from the different dimensions. Then the next one is operations. So what kind of operational methods are implemented to enable and sustain the commercial and scalable BVLOS drone services. So that's another dimension which we assess in this sense. The next one is the technology. So as we discussed yesterday, some countries already in Europe implementing the UTM services or use-based services. And we also understood that the understanding what's the UTM and what's the technology behind that is sometimes different. So we try to assess, relating to that, the specific standards, what technology was implemented or is planning to be implemented. And the last not least is the business and market. So at the end, we are doing it for business. Obviously, safety is important here, but without business objectives, all of that will never happen. So we also try to understand if there are specific measures implemented in the country level or the organizations level to measure the business and success of this implementation in the context of the drone services, because that's like an ultimate goal. And finally, we are aiming to provide the best practice from the regions and the countries. We make it in the best way and most sustainable way. So we are planning to prepare the best practice that other countries or regions can implement and just rely on. Okay, so what is the way how we approach that? As mentioned, we create a survey, we send it out, so then we approach the GUTMA members and really public stakeholders. But we look for the governments, so the CAAs, ANSPs. We also look through the service provider, technology vendors, and end user customers, and our other drone associations. So that's the really broad spectrum. And we also take some really great collaboration with Unmanned Airspace, Philip Butterworth. So very thank you to him to share with us his recent publication about the global UTM and drone business. So this was very helpful also to gather more information. As you can imagine that you probably been you already receive a lot of emails with surveys. So we also facilitate that some countries been maybe missing our emails, or maybe we're missing the opportunity to share. So we didn't receive all information from all regions, but we really received significant inputs here. So we already get the good feeling what's going on here. And how we assess the UTM ecosystem maturity, how we put the measures here or scoring matrix. So we set the 5 different levels to make it easy for the recipients. So nascent, emerging, developed, advanced, and mature. Scaling up, mature is really that something is implemented and ready to go and really fully deployed. And finally, we combine all the stakeholders together, inputs. And as mentioned before, in November, we'll be ready to publish the outcomes here. Small pause. if you want, you can take your smartphone, scan the QR code, and go to the survey. So you still can submit some answers and questions. So answer our questions, and really it will be really helpful because we are still seeking more information and we are still seeking the broader perspective. And if you want to share with your friends from other regions, please go. This is not just for youth space and Europe, but this is globally, and it will help us to better understand how the UTM business and how the drone business is growing. Hopefully ready, scan. So finally, we are in halfway. And as mentioned, and this is the point of this presentation, we have the first feeling what's going on there. And maybe you can sense it. This is not perfect. This is not really great, but we are moving forward. So from the legislation perspective, there is a slow progress in the national implementation of the EU-based regulation. And mostly we see that countries implementing 947, 945 regulations. The EU-based regulations are touched. Some countries really contemplating that. Some countries start implementing, but this is not the majority of the implementation. Governance, so that's really interesting that as we all understand the discussion as we are here is really important, but we sense that this is insufficient culture of cooperation between the public and private, which doesn't really make it happen. So it doesn't make happen the drone service are scaled and UTM is deployed with the mindset that we all understand why and how to make it. So that's also coming to the conclusion that strategy is not there. So I barely see the country which created the strategy about the UTM and really publish it and make it across the different ministries. Because this is not that CAA on one aviation institute will make it. It has to be across the whole stakeholders in the country. Because drones will impact the transport, economics, and also in development of the components there. So there is various levels of the value which drones can bring, and UTM is just the enabler, as mentioned before. Operations. So as we learned yesterday, there are a few ongoing use-based regulation, which is not enough really. So there are countries which even not thinking about the use-based because they are still in the 947, 945 regulations. And they don't have resources, maybe because they didn't set the strategy, so there's no stakeholders aware that has to happen in the proper way. Technology, we are facilitating that there are basic airspace, geo data, geo awareness tools available, and that's pretty well distributed. But when we come to the advanced UTM technology, so use-space, there is really few truly use-based services enabled there, which even are on the way to be enabled. And the last, the business. So I like that topic because it's really the sense of all the markets, the development, and there is no really tools which can measure the success. And I think the Jarek is here. So I really like the point that Polish CAA achieve the level that we have, I'm Polish, we have 250,000 pilots registered. But the problem is that when I ask, what is the business out of that? So how this 250,000 registered pilots, which are very active, and in the Polish scene, there is a lot of pilots flying, how it's translating to the business? What is the growth? Nobody can answer that. And I think this is really common for all countries, that from the CA levels, you might be proud that you have enabled a lot of flights, but at the end, we don't know how that translates to the business. So we cannot really measure if it's successful or not. We cannot measure if UTM implementation, use-based implementation will be successful afterwards. So I encourage that we have to think through this as well when we talk about the use space. So we are not yet ready with the outcomes, best practices to share, but at least this is the first view how that looks like from the perspective we got. And from the discussion we all have, and also from the yesterday feedback. And maybe my last comment here is that we are focusing to build something so safe that at the end we have no flights. So thank you very much.
Okay, so thank you very much, Sebastian. Do we have questions? No.
No. Okay, thank you.
So anyway, you have questions for Sebastian. You have questions.
Thank you. I suggest to add to your questionnaire a simple question. Do you already have a way approach the state aircraft in order to establish a mechanism to ensure the access to the U-space airspace from military, police, firefighting, and other traffic that to which cannot be denied the access to that airspace? Because this is, in my view, the biggest difficulty that we are facing in this moment. Thank you.
So you're asking if we address. So can you repeat the core of the question? I didn't get that.
Yes. Looking at this idea, these days, it is they are very drone focused. I mean, drone population focused. But their space is a resource which is shared with people that have rights, access rights that cannot be denied.
Okay, I got it.
So when you go to the state aircraft, they say, I don't care about your space. I want to go there. I have no money to become conspicuous. And you have to grant my access there with 3 million warning. That's, I mean, what is the real issue? If you have already solved this issue in your country, you are very close to the solution. Because after this, you just have. So my suggestion is to add a question like this to your questionnaire to say, do you already find a way to ensure the access to U-space, airspace, to state aircraft? Because this is very important. Thank you.
Okay, good. Got it. Thank you. So we didn't ask that. We didn't thought about this as the area of our members, and the scope was never touching the manned aviation, but we will consider that. Thank you for the suggestion.
Thank you very much, Luca and Sebastian. Any other question? No? But then thank you very much again, Sebastian. And now we move toward the IAM Hub. So yesterday you have heard from Florian, from our executive director, and also from the commissions. It's one of the flagship actions, and it's definitively one of the most important projects that we have at the moment in the Innovative Air Mobility program. And the program manager or the project manager for it is Kai Bauer. So the principal advisor for sustainable mobility at the EASA, and he is supported by Christina, Suomi, Helsinki U.S.-based project director. Christina? Online. Online, I didn't know. Okay. Then Kai, the floor is yours. Thank you.
Yes, Maria is online. We'll connect still as a team. So good morning, everyone. Real pleasure to be with you this morning. The early morning session is never the greatest spot, I guess, but you all look very fresh, so that's a great start. Thanks to the typical Cologne weather, I guess, that we have today. On the IAM Hub, I think it connects well to the previous presenter from GUTMA, in the sense that the work that we're doing with the IAM Hub has been originating from a survey, actually, that we did around societal acceptance. And that's really at the heart of the activity that we're doing. So all we discuss and all I show you on the system and its capabilities, we should all see it in the context of how much added value does it bring to promote societal acceptance of the activities that we're doing here, that we are ultimately integrating new way of transport into the system, into people's minds. And we are here in a building that originated from the rail transport, and in a way we're closing a little bit the circle, because with drones you're also doing services for the rail industry. And I think in the beginning of rail traffic there was also a lot of need to convince people that this is not too fast, not too dangerous. So I think every time you introduce a new form of transport, you need to bring people over, and that's what we're trying to do here. And that's what the IM Hub ultimately is really about. Christina's online. She will present in a minute a little bit the perspective from the city at the moment, what their pain points are today, and what they're addressing, what they're trying to solve from a societal benefit perspective. So we'll have that in a minute, with the main idea for this session this morning, of course, to bring you up to speed what the IM Hub is all about, the current and future capabilities that we'll be showing you, and collect some feedback. So I can already ask you to switch on your Slido. There will be a question. There's already a question, I think, activated right now around what you think are the most important elements and actions to increase societal acceptance from your perspective. It's a free, it's a word cloud exercise, so see what this results in. You can continue and enter the words in as the presentation goes along. And then, of course, as I mentioned already, Christina will present the city perspective. We've gone through a couple of releases with the IM Hub, still at the version in the first phase, in the pilot phase, as a minimal viable product, as the world of IT would call it. You have the links there. But just to give you in a nutshell the rationale and mandate, as I mentioned already, the origin was really the societal acceptance study that Philippe Collet also mentioned yesterday, that identified a positive sentiment across Europe for drones and innovative air mobility, but with key concerns around privacy, of course, about safety, about noise, and environmental protection. And I think that's a very important one as well, about the need to build trust and bring all the actors in the system together. Because I think that's what we see also at European level, that some frustration on citizens is created by the fact that they don't have one problem, and on the other side, that they have multiple actors that are needed in order to solve that problem. So I think that the notion of bringing together people in a multi-governance exercise was very important here. And then based on that, the European Commission added the IM Hub as one of their flagship actions to the drone strategy 2.0. So that's where we are, and we've now essentially you see the timing down there on the phasing. We have the pilot project that is essentially now closing, and that's what I present you now, what we have done and achieved in terms of capability in this pilot project, and then of course we'll talk a little bit around the future on that. When you get a task to discuss, okay, build a multi-governance platform to address societal needs, of course, the first thing to do is to sit down with those who are involved. And we created a task force that really rebuilt and the entire ecosystem with actors from the ecosystem at all governance levels. So that's why you see here the cities and the regions at the heart of the task force that helped us to build what you will see in terms of functionalities and capabilities. Starting very modest, as you will see, but you have to start somewhere. But it was important to have all levels. We have the Commission, of course, involved. We have the member states involved, very importantly, and then manufacturers, the vertiport and operators, USSPs, all represented in that task force to help us give it a very good first shot. Now, based on that, we designed essentially the capabilities of the system around these 4 packages that you see here. It's about connecting the communities, because that was a pretty clearly identified element. It's about communicating IAM impacts. That's very important around noise and sustainability elements. It's about supporting implementation. Everything we do, and we will see a bit later, on digitizing rules, simplifying rules in a tool. That's what we do in this implementation support. Of course, giving guidance is there, and centralizing data. to have that one-stop shop of data, knowing that building trust is a lot about having consistent data sets and consistent information. People start distrusting when they quickly see on Instagram one figure there and a different figure there. So that creates mistrust. And what we're trying to achieve is really a common approach on this. So that was developed with a task force, these 4 components of capabilities that were then translated into an actual IT system, a cloud-based system, which has essentially 2 technical parts, a public zone and a partner zone, as we call it, with functionalities to address content-wise the themes that we have identified, safety, sustainability, noise, privacy. So you find themes on the one hand and actual modules of the system on the other hand. Noting that there's as I said, there's a login part, a partner zone, and a public zone of the system. The rationale of the public zone is, of course, that nobody today actually goes to websites to find content, but you Google it, you use search engines. And the idea was that any public content has to be really searchable. As far as the partner zone is concerned, we first implemented the foundation around the drone and design database. And that's also where the current login works. So if you go to our website, there's a login button that actually leads you to this part, but it's at the moment open widely only to manufacturers in order to enter the drone data. So inside that partner zone, you have these functionalities, the drone design database that are already mentioned. That's the first element there, where the manufacturers enter the drone data, which is partly exported to the website for public consumption with certain fields. But most importantly, it's accessible to member states to access sensitive, specific technical data on each drone to be used in their authorization processes. Currently, the EASA DVRs are, of course, in there and CE mark drones. Then it's a multi-governance system so that you have the possibility as a member state to assign also local authorities into the system to allow for that multi-governance conversation. We have started to implement some digital rule support. So that's the critical area calculator as part of the SORA. This tool we've been also exposed to the website. You will see that in a minute. But it's the first step towards this the thinking of let's simplify via digitalization so that people don't have to do all the thinking in the background that has already been done. And as a fourth component, we're testing with the Irish authority the potential that's implemented right now to allow for operational declarations based on standard scenario through the system. So that operator goes on, picks a drone and the standard scenario, and then it's declared to the authority. So that's a little bit the high level that we have created in that context for the partner zone that's inside behind the login. Now, when it comes to the public part of the system, as I mentioned, the idea is that you should be able to just search for it without having to know that even an IM hub exists. That's why the data is fully integrated and in our website, and why the actual best starting point is simply the EASA domain for drones and air mobility, because we put all the information and all the tools that we generated that are made for public consumption are simply there. If you go to the current website and to that domain page for drones and air mobility, you will be able to see access to these points. We have some basic guidance for cities that we still will be expanding on. We have some the drones database that I already mentioned. So that's basically a public part of the drones database behind the login, where we have the list of drones that are currently in operation in Europe. And most importantly, I think from many perspectives, these boxes on rules and guidance that you see on the right-hand side, because there you get really the links to all the information that we've generated, partly from the hub, but also mixed with other content. I will talk a little bit more on noise and sustainability in a minute, so bear with me on that one. But that's essentially what we have in the public part of the system. As I mentioned, we already also exposed on the public part now on the website the critical area tool, which is simply you hack in the numbers and you get the results for the critical area of a particular drone that is part of a SORA process. And the idea is to gradually integrate that in the eSORA tool that we are developing. A bit of geo stuff. Drones, you guys, drones is a lot about where to fly, of course. It's all about where to fly and where to operate. So there's some geo information in the system, some about statistics. So if you want to know how in your member states, how many drone authorizations are being given, then go to this place with a map that you see there. And if you click on it, you'll get the data from each member state. And we started to test the transmission of geozone information and public and population density data from statistics, static population density data. So that's what we currently have. You see that online, and we're testing to see how that is best distributed through the system. Before I talk you through the benefits as we see of the current system, let's have a look at the results now from the cloud. See if you have typed in some ideas on how societal acceptance can be addressed. We have some results on Slido for the World Cloud. Let's just to check if we are on the right track here with what we're doing on the IM Hub. And so the question was, what are the most important actions to promote societal acceptance? All right. Yes, I think that's very encouraging because it's spot on to what we started with actually for the IM Hub. So at the center, low noise. Well, actually, that's a little bit larger than I expected, but okay, that's definitely an element that we see. Safety, privacy, and confidence, trust. I think that these are the elements that we also do see a lot, and that's. As I mentioned, building trust is a lot about having consistent information from a trusted source, and that's what we're trying to achieve with the elements. We certainly try to positive impacting ops, so that's something where I think we can also continue to work on. So I see that the preferences are shifting a little bit as we talk. Interesting. So we'll have that recorded and we'll take it away. Will help us to also drive future activities in this area. Thanks a lot for that. So the benefits, if we're going back, keep going. Yes. The benefits of the system. I will not spend too much time on this now, but the benefit of the system that we do see and we've developed. I think the most important message is that we have identified benefits and linked capabilities for all the actors in the systems, from the citizens, municipalities to the EU system. So that's basically what's driving the capabilities that we have. Now going into the next phase, what will happen next? We have just launched the second phase of the IM Hub. So we are now in the phase 24 to 26, and we've developed some with a task force some priorities and work packages for that, and we would really like to hear your feedback on those today. So what we will be focusing on one area is develop and closely with the member states. There's a meeting with member states later this week, because of course we want to integrate as much as possible with the member states, their activities and their systems. And I think here we are working very closely with some member states already, and we intend to make sure that this is a smooth experience, also in terms of what functionalities are provided at the EU level and which ones are at member state levels. Digital rules, I mentioned already, and I say a bit more on that, and noise and environmental footprint, that's a big focus. We work with pioneer cities like Helsinki in order to develop the system in such a way, end-to-end, hands-on in one city, so that it can then later be rolled out. We don't have the resources to go in all cities, but to have some hands-on experience there. And we're working on where API makes sense, because we have some operators that have basic functionalities, basic authorizations, which might not need APIs, but others, of course, more sophisticated systems where APIs will play a role. A little bit of a glimpse, what do we mean by ESORA and digitalization? So really it's the idea that we take people digitally by the hand and guide them through the ESORA process, calculate the ground risk class and declutter a little bit the system. And that would also help to, of course, standardize the way these kind of SORAs are being done, and spitting out in the end a application form that can be sent to the NEAs. And because NEAs will be part of the system, of course, and are part of the system, what the outcome will be more standardized, we hope improves quality of the applications. That's one package. The other package that I wanted to mention, meet Nora and Eva. That's all you have to remember. So Nora on the noise and Eva on the environmental footprint. These are the methodologies we've been developing, and we've been actually measuring drones on this. So bear with us next year. You'll hear more on this with actual data, with the idea to have a tool that allows noise impact assessments for actual operations and environmental footprint information. So how much less CO2 you will have if you use a drone on a certain use case. That's basically the target. In the middle, a couple of birds. That's what we're after there with some researchers to work on how we can also help to address the wildlife concerns. So there you go. That's a little bit what we have for next year. So expanding, of course, more countries in terms of the GeoZone collaboration, more cities. And when I say more cities, that's a good time, I think, to see if Helsinki is online. Hello, Helsinki.
Yeah, good morning. Hello, Kai. Thank you for your presentation.
Good morning.
Good morning, Christina. Good morning, Yuka. It worked well. We are like a bit like in a Eurovision Song Contest, but we don't ask you for your numbers, but and your votes. We ask you for the city perspective from Helsinki. Looking forward to your presentation, Christina.
Yeah. We'll do that. Just a sec. Share. Let's take this one.
Yes, we see you. Good morning.
Okay, excellent. Thank you so much. So good morning, everyone. From Helsinki, from both of us. We are from the Helsinki Youth Space Project, the 2-year-long project for looking for the cities, city of Helsinki's position in this reform which is happening in the aviation. So what I'm telling you is that the cities like ours are more and more getting interested in what is happening on the low urban airspace above the cities. And our way to understand, gain understanding, our own understanding, but also build up the trust, communication grounds, and communication ecosystem is the digital twin. There's a big picture, and for you to demonstrate how we do this, first of all, we do have aviation expertise. We do have strategic spatial planning expertise. These two are put together. We use some 60-70 of our officers and workers to produce, update, redo, do revisions on our aspirations. And I'm talking about the cities, the municipalities' aspiration about the usage of its urban low airspace. Digital twin, it's not losing any data, everything is collected. And this is the way to really communicate between the institutions such as let's say today with EASA, thank you for allowing us to come, but also our local aviation authorities, aviation institutions, ministry, legislative people, etc., which we are not familiar with. This is the first time we are really getting involved in what comes to aviation industry, aviation actors, and the whole environment. So it's about building new. We also see that the next phase after building up the trust and communication grounds between the institutions, the next crucial step is the public participation. And in there, the 3D format of the digital twin, it really is the smartest, fastest. It is already economical, safe, and enables machine-readable data flows in the future whenever the things go forward. I show you one example that we are facing already, and by learning through the digital twin and demonstrating and communicating this, the 3D digital twin is used, for instance, in planning the drone flight route. This is a test route in Helsinki CTR, Helsinki-Vantaa CTR in the center, where actually the whole route, total length 11 kilometers, is overlapping the CTR for 600 meters and 1.3 kilometers, which is the red dashed line. This is demo test flights, which are between the depot and the healthcare center. And again, telling about how we as a city, as a municipality, and the surrounding cities and municipalities, how we see, for instance, through learning and getting more, gaining more understanding in the lower airspace. This is the desired goal, reformed CTR here locally, where 700 feet would be desirable CTR SFC. We also have discovered that the positive effects of this new narrow CTR would be that it enables this green carbon neutral aviation establishment in our area, new businesses. It would also give easier remote control handling when it comes to air traffic management, and enables focusing on main air traffic. So it's a super good learning what we're doing here. This is the challenge description in more details. There you see the local CTR. Now this all information is it is in our digital twin. So the owner of this challenge is the city of Helsinki, our municipality. The duration of these test flights would be 2 weeks. And objective is to take transport medical goods of the most essential products to simulate pandemic crisis with real flights. And what I would like, and my call is for all municipalities and cities to really build up also the know-how of the urban air mobility and the urban airspace within its officers and practitioners. I would encourage the cities in Europe to really establish the kind of a center or a group or like what we represent here, putting together the aviation and the land use planning together, because in that way we can also give and build up understanding in a very professional way to the aviation authorities and institutions, and in that way also build up the trust. So here, for instance, is in aviation language, which actually I can't speak, I can't write, but my colleague here understands it. And together, when we put these two together, we can go actually much better forward than ever before. So this is our handout to give for better understanding to those who maybe face the similar situation, not being able to do the drone flight at the moment because of the situation, let's say, establishments from leaning on the conventional airspace usage. Now that the new is coming, we've actually learned some lessons which we've listed here. The fact is, I think the shocking fact is that it's actually easier to arrange a cross-border drone flight connection between Estonia and Finland. What I mean is our twin city, Tallinn and Helsinki, than this local 11 kilometers. So the delay time for our test it's been quite long. Actually we have a very ambitious carbon neutral strategic program here in Helsinki. And so we actually see that this large CTR is obstructing the development of sustainable urban aviation above our airspace. And what we see from the city's point of view, that the CTR requires reform nearby the urban areas due to the city aviation. So we've also brought up some ideas and corrective actions for rearrangement, which are listed to the right. Perhaps the allowing separation between aircrafts, both visual line of sight and beyond visual line of sight drones or area of drones. We look into both vertical and lateral points of view. And then, of course, the CAAs could be able to make permit decisions independently without a statement from service providers. So these are also what we've come as a city, come up with some ideas to maybe think about. But to conclude, the digital twin, starting first the communication between the institutions, aviation authority and the ecosystem, and the next step definitely and very carefully, very cautiously, the public participation, which needs a lot of attention, which I believe the cities and municipalities are very good at, and being the partners in this transformation. So thank you from our behalf, and I wish you all a very good seminar and there in Köln.
Thanks a lot, Christina. Very well received on this side. Very, very clear. We hear messages. Please stay on the call a little longer. I guess there will be some questions for you in this context. We hear your message. I think it's very clear that you have a very clear vision of what kind of benefits you want to bring with drones and air mobility, and you're providing some solutions. I took note of the technical proposals you provided. I will quickly hand them over to EASA colleague. See what they do with this. You see that we will have, as I mentioned earlier, also this week a conversation with the colleagues from Finland. So. With that, I would like to just have a quick wrap-up call for what you can do now, and then we have, of course, a question and answer session, and Christina will be also available for that session. So, just as a quick wrap-up, you've seen the journey that we've taken with the hub. We're integrating the system. We are basing it on what the needs are in the cities, as Christina has described. We are on that basis calling for you, of course, also to help us and support on that journey. There's two concrete areas. One is for those of you who manufacture drones to, if not already done, to register with the system and put your drone technology on the IM Hub digital platform. And the second part is to provide, of course, feedback for the phase 2. For that, I would open survey again to get the question from you and sort of a live answer on what you think we should focus on in the next phase from what I just presented. Of course, this will not go away. In the presentation, you see a link also to a feedback form that you can use later on. But let's see what the surveys come up with, what we should do next in the next phase. All right, okay, that's a big call for the population density data that we started. That's also already on the tool and coming from Copernicus, another European important project. Provide digital rules, EASA, and geozone data. I think that's a very clear ordered message. For the geozone data, of course, we are engaging with the member states. It's their responsibility. And maybe talking about responsibility as a one important message, of course, this is a digital tool, it's a platform. It's not changing responsibilities, of course. It's just supporting in the system that we are working with. So thanks, that's extremely useful. I think we can just go back to our desk and start working with that. And I think now it's a good time to open the floor for further questions through Slido. And thanks, Christina, for still being with us. Maybe there's also a question for Christina on the call. Yes, the login question. We had that a number of times also yesterday in the call. So as I presented, we have at the moment the login that is for manufacturers, drone manufacturers, who get all of them get access to put their drones inside the tool. The other login part is only for task force members where we're testing certain functionalities. So for other users of the system, please bear with us until next year when we have worked through the tasks here to see what other functionalities will be provided through behind the login. Otherwise, we ask you to present your comments on any other functionalities. For example, the population density data is accessible through the EASA domain on drones and air mobility. So that's really the content part, the public domain part, where we're also looking forward to any question from you. And again, on the population density data, on the unit, that's something we'll take back and fix, because the intention is that the tool, of course, uses the same units as the SORA tool. The question from Christian on the geodata. Yes, that's why I'm mentioning the geodata is something where we are cooperating with the member states. This is clearly, of course, a member state responsibility. We are discussing with member states under what condition there could be a one-stop shop and a redistribution of the data and how that could be implemented. So that's the what's of the SORA process will be covered by your future SORA tool. I don't know if the colleagues want to complement, but essentially the idea is that we do the SORA process end-to-end in the tool. Ground risk class, air risk class, and the final documentation. So it's an end-to-end process of inside the tool, but of course for basic applications. So we expect that we try to simplify things where things are relatively simple to start with, and there will be plenty of other areas where this tool might not be sufficient. I don't know if the colleagues from team want to comment on this. Any question for Christina on the call? Maybe Christina, since you're there, it's out of my curiosity on this digital twin that you have. How do citizens react to this digital twin that you have set up in the city?
The thing is, we have not yet. We haven't communicated yet with the citizens. However, our innovation company Forum Verium, through the EU project called CityAm, has together with cities such as Hamburg and Stockholm made polls. Not polls, but questionnaires about this coming, and they are actually producing understanding through that. Now that when we are planning how to actually start and do the public participation. This is something pioneering work to which we don't really have references. However, we try to use the best practices, what we have learned from the land use planning, which is transportation and land use planning. It's the both. Mm. So strategic spatial planning methodology, that possibly, and this is when the planners, the city planners, urban planners, and regional planners, when they can be, and possibly, and this is my prediction, that this is something good that the cities and regions can bring into this process when communicating with the public and making advances in the public participation. So the answer in short, we have not yet done this. We are planning, and once we do, we already predict that the 3D format digital twin will be the tool.
Thanks a lot, Christina, and thanks for reiterating the interaction with land use planners. I think this is an important element because it unlocks, of course, market potential for the industry, because the city planners are those that have problems like we all have. They don't have enough people. They have objectives around decarbonization. So there's many cities are part of the decarbonization effort and have committed to decarbonization, and drones are, of course, great to help with that, to understand traffic pattern, to look at the green spaces, help to manage the green spaces in cities. So there's many areas where drones can help with that. And if you have access to the city and land use planners inside the city, you're opening up these markets, which with the understanding that you're creating in that area. Thanks for that, Christina. I think I've time for one more questions. Thanks for that idea with the MOC. That's an interesting one. I think that's certainly one to be considered, and might help to facilitate in the process. The opening of the hub for operators, that's definitely on the cards, because some of the functionalities that we do see and that are obviously for operators of interest, and we will make sure that operators can access the tools, so definitely that's on the cards. So next year you will hear more from us on how that can be accessible to operators. And maybe the last question, because it's quick, on the 318, the compatibility ED 269 and 318, clearly 318 is what we're going for, and we see the IAM Hub to provide verification tool and the standard to comply with 318. So that's basically what we have in the pipeline for the next year as part of the geo zone work that we are doing. And we will be covering, as far as EASA is concerned, 2.5 in the tool. I think with that, we are pretty much at the end of the time slot. And thank you very much for that very engaging discussion. Great questions and interesting cloud results. So thanks a lot. Very, very inspiring. That will help us to steer the next 2 years for the IAM Hub. And we will certainly see you again in different ways of communication. We're working on different ways to engage with you next year, to widen the circle of engagement. So looking forward to see you in that context as well. Thank you very much.
Thank you very much, Kai and Christina online. Very interesting presentation with proposal for CDR redesign. I took it. Will be interesting to talk about more with Christina on this. So now we go to another interesting topic. So enable BVLOS operations, their risk perspective, and we will touch upon 2 topics. So an update on inconspicuity and ADSL Lite by my colleague Vladimir Foltin, who is the project certification manager, general aviation and ATM expert at EASA. An update on GNSS issues by Stephane Vaubourg, You already know him from yesterday, so US Space Project Manager.
Good morning, everyone. Extremely pleased to be here with you this morning. Me and Stephane, we will go through this interesting topic. I think the agenda outlines these two topics. I will focus on the first one. That will be most of our presentation, and Stephane will complement with the GNSS issues in the end. And I hope you find our presentation useful. Thank you, Maria, colleagues, for the opportunity to present. So when I was listening to the presentations yesterday and also this morning, I've noticed or I remember two key words from what I've heard. And it's cooperation, collaboration. And that's going to be at the heart of my presentation. And also I've heard a lot of times, much more than in the past, words situational awareness. And this is what I will be talking about, what we will be talking about in our presentation. So let's start. Specific word, iconspicuity. And let me share a story with you so you get a better understanding what we mean when we refer to iconspicuity and how it relates to electronic conspicuity and conspicuousness of aviation. This is a concept word. By the way, this little I in the beginning is initially it was intended to be inverted acclamation mark. So it's not I per se, but we started to use I because it's easier to type. You do not need to use Alt key, just put I. And then it was to highlight the key word conspicuity. That's what the key words, what you should take away. It's a concept that in simple terms means connected aircraft for enhanced or better situational awareness. It's not a detect and avoid on its own. It's not a surveillance. It's not tracking device. It's a concept that describes connected aircraft for the purpose and sole purpose of enhanced or better situational awareness. Of course, since the start, we were very clear that whatever we do to save lives of GA and rotorcraft pilots, we will remain closely tied to U-Space ecosystem, to closely compatible with U-Space developments. By the way, the existence of my presence of myself here in front of you is a good example of EASA collaboration. I'm not integral part of Drone's team, but we have a very close collaboration, and I would like to thank my colleagues for that happening over the years. So I'm in the GA area mostly, and we work closely to provide solution for both drone industry and GA. So iconspicuity, it's a concept, it's not a technology, it's a concept of connected aircraft for enhanced situational awareness. And this could be pilot, but this could be a drone operator, this could be those on the ground. We have seen the authorities might be interested in data. These are also those who provide services or conventional ATM. Okay, so next few slides will highlight the outcome of a close collaboration effort between the two major aviation organizations, pan-European aviation organizations, EASA on one hand and Eurocontrol. We have teamed up with brilliant experts at Eurocontrol, and we've reviewed iconspicuity concept and jointly agreed a roadmap for its implementation over the next few years. And the next few slides will dive into the main elements of that roadmap, so you have a comprehension and you understand what will be the steps taken by these two organizations to make it a reality. So first of all, we have agreed that we will focus on the 3 use cases. The first 2 ones are primary use cases. The second one is subject to further work. The primary purpose of eye conspicuity is to reduce collisions in the air, and other airborne hazards. Because if you bring the weather information into your cockpit or a dynamic airspace into the cockpit, of course, we can better utilize the airspace. We could address other hazards. The second use case is to keep easy access for manned aviation to U-space, especially when U-space is going to be deployed in airspace where no air traffic services are provided to that traffic. And third, but not the least important, but it's equally important, is to provide additional benefits. We see a great potential for enhancing the existing services we have by better situational awareness. Again, it's not to provide services based on eye conspicuity, but to provide better situational awareness for search and rescue and flight information service. We don't think about changing existing rules or procedures. We see this as additional layer of information for situational awareness, for contextual awareness. How we will be undertaking these steps. Okay, so I've jumped over. So this is the next slide. Sorry, target solution. So we have agreed, and that's here is one important element on this slide, which is slightly different to U-space, and I would like to highlight that point. We are dreaming of U-space and starting to implement it, but it's clear and obvious U-space will not be every day tomorrow, maybe not even coming years. It will be in certain local locations, geographically limited locations, where it makes sense, but it will not be everywhere. However, our problems of collisions, we need to address the problem all airspace. And in order to address the all airspace problem, we have realized that we need one important element in the future solutions. And that is that we need a direct capability between two vehicles to communicate with each other. We cannot rely solely on network infrastructure in any piece of airspace. We talk about higher altitudes where network services might not be available today. And we need to address the problem today. So we confirmed, both organizations, that the solutions should be simpler and very affordable to end users. And their expectations, these are their expectations. This is where they are ready to adopt these technologies. And they need to be interoperable across the board. They want to be sure they buy a solution from a partner and it's compatible with other solutions from other manufacturers. And this is what we are working on with industry quite closely, and we have made some important steps towards this direction. When it comes to communication, and this is the element of a language, we need to have an interoperable language these devices could communicate with each other, either through the network or directly. And we have concluded that ADS-B international standard and ADSL, as developed for U-space conspicuousness, are very good candidates to look at and maybe compile a language that is meeting wider range of use cases as outlined in the previous slide. And then one link. I've mentioned this direct radio line of sight link for speed of sound communication. Don't please understand this being necessarily only one frequency. Please understand these links as a described ecosystem which works seamlessly. It may be 2 or maybe more frequencies, but which are documented and which are transparent to device manufacturers, and they know how to implement them. And we are not excluding a mobile network or network connectivity. We see it as a complementary for these use cases, because we are not concerned about latency of information if we are looking for strategic information like traffic, which is 10 kilometers away from my position, or weather update. We know that weather radar is updating every 15 minutes. So seconds is not concerned there. And this is where the network connectivity could be perfectly stepping in and offloading the main channels especially when it's available. So one link is not necessarily one frequency, it's a properly described ecosystem, how this all will work together. And in terms of technologies, these are the candidate technologies we see as opportunities for use case, for demonstration and implementation of use cases. We have our unique 1090 megahertz a lot of critical communications happens there, so we have to be very cautious. This is a standardized, globally deployed channel, but we need to be careful how we deploy on this channel because we cannot afford endangering EASA function or surveillance services in Europe. It would be absolutely unacceptable. 978, great potential, it's aviation's frequency, but we have some struggles in Europe to deploy because it needs to be protected, so side channels are to be protected. And also there is a consequence on, it's a licensed frequency, so you need to have approval from aviation authorities to operate on that frequency, which is a burden for many, including drone industry. So imagine every drone operator operating a drone on that frequency would need a radio license and test and pay a license fee every year to a telecom authority. So that's not what the community of drones and GA want. So the expectations are different. So we will work on that, on those concerns. SR-860, it's used today with these devices. It has potential to provide short-term noteworthy improvements in our safety system. The downside is that we are not alone on those frequencies. So there is an interference problem, which could be overcome to some extent, but it exists. As well as it's uncertain beyond 2030 what will happen with this frequency, especially with the enormous pressure of telecom industry they're attracted by those frequencies for advanced communication. So we need to work on those to ensure that we have a channel in the future that is supporting this one link. Last but not least, mobile telephony, a great example for larger books of data. We have it broadly available with today's technologies, but it can be deployed in any airspace we need to be deployed it. But again, it's missing this direct speed of sound communication, which is essential where the devices are close to each other. So that we cannot rely on latency of the network in that sense, especially when we are not in the use-space ecosystems and we talk about any piece of airspace. Okay. The approach we are going to undertake is we will look at closely at the use cases, those which were presented, and the key word there is pilots or ground services situational awareness. And we will look at the use space conspicuity, and we understand that the use space will be deployed initially at smaller geographically limited areas, and typically at a very low airspace. So the use space is not expected to grow tomorrow to higher altitude. So that's our approach. We will have to consider use space mandate. The use space mandate, by the way, is expected to be the only mandate we will utilize for eye conspicuity concept. There is no current thinking, I cannot predict the future, but currently there is no thinking and intention to impose conspicuity outside of use space. Instead, we would like to make the burden and obstacles as low as possible, so everybody who flies outside of use space from manned aviation perspective will gladly accept and equip himself with electronic conspicuity devices. So voluntarily elsewhere, mandatory in use space. And there are some different expectations in GA. We all know that the GA is not homogeneous group of users. Actually, it's very diverse. Some people consider GA business jets, and on the other extreme, you can have paragliders, those who are flying balloons, hang gliders, gyrocopters, all those planes flying a lot. By the way, all of those are half of the traffic we have in Europe in terms of number of movements. So there are different expectations from IFR pilot and glider community, or even paraglider community. They have their distinct needs. So we will look at those, and we need to consider those in our work. And we also need to consider that there could be a good case, dual cases used, like, for example, ADS-B is a good example for being conspicuous in U-space airspace, at the same time to be able to benefit from services of air traffic services as IFR traffic. So that's a potential we will study closer. In terms of assessment, we will look at those candidate technologies, and we will try to compare the options and provide the best analysis, but not only from the perspective of one user group, not only from the infrastructure or services perspective, like NSPs. They may have their own needs and perspectives, but we have airspace users, we have aviation authorities' expectations. So all these aspects would need to be put together and analyzed. And last but not least, and this is not a last point, but we will be communicating throughout the process. This presentation is one of those communications. We are starting with the implementation of the roadmap. We're communicating to you openly what is the status, what is our plan, and we will be communicating to you throughout the process, both through EASA channels and Eurocontrol channels. So in terms of timelines, we want to come up with one language proposal pretty soon. We would like to have one language proposal early next year to be presented to the communities. And I will again remind the candidates we are looking at is ADS-B and ADSL, and both of them have their good points, but both of them currently have their own weaknesses, and we would like to merge those positives and eliminate the weaknesses, hopefully. In 2025, we will undertake comparative assessment of options. So in the end, we will be able to give you the MOAT proposal of the one link or consolidation of one link proposal in 2026. That's important also in terms of World Telecommunication Organization. You know, they are meeting every 4 years. Their cycle is typically 8 years. So we would like to have this being presented, I think it's 2027 is the next World Congress. And then it will take at least 4 years until the implementation means are made available and this being agreed, hopefully in early 2030s. So that's our plan. We keep it consistent with the spectrum. The key role of EASA, as we see in all of these, is to work on this one language and also on the spectrum aspects. We have in close connection with Eurocontrol, but also with the European Commission, who are made aware of this, and hopefully they will assist us all to get a good spectrum and good link for iconspicuity in the future. Moving forward, this is one slide I would like to use just to raise your attention. I will not dive into the details of the slide. It's impossible to do it in a few minutes. This is to raise your attention about a project we have concluded with our partners on iconspicuity interoperability. And that slide outlines the future of iconspicuity as seen by the outcomes of the project. It's a combination of certified and non-certified technologies airborne, and also utilizing the potential of mobile telephony, all underlined with the ground network, but fully scalable approach there. We don't need to replicate things. We can have a very light and simple solution being implemented. Cloud technology we have seen for AAM Hub and other things. We have seen some technological solutions for U-Space being using cloud technology. So there is a great potential of digitalization in there, but we need to work on those. Go to the website. There is a lot of information. There is a final dissemination event video you can watch. And in case of questions, don't hesitate to contact us. And last few slides I have is about ADSL. So by all this work on iconspicuity, we have been addressing interoperability and high cost concern from pilots. This slide is, by the way, 5 years old, and those tick boxes are basically that we were looking at those. But there is a growing concern out there. We have mandate for U-Space. We don't have mandate elsewhere. we start operation in accordance with SORA. You can operate today, and these operations are taking place beyond visual line of sight, very low airspace. SORA 2.0 and also SORA 2.5, which is in adoption process, both allow you to operate in very low density airspace, BVLOS operations. If you are capable to detect, or if you can demonstrate as a drone operator, you can detect 50% of the traffic. And that's what the situation today. This allows drone operators to do long distance flights, especially in areas when there is one drone operator operating. There are not many in specific category. And this, of course, could be a concern for GA. So we are trying to use this information as an incentive for GA operators to recognize that there will be drones operating, let's say, below 500 feet in rural areas, early in the day, in the night, or throughout the day. And these drone operators have this requirement. So it's better you are equipped. And if you are equipped with incompatible technology that is not recognized, then this drone may not be able to detect you. But you can bet as a pilot that if you are equipped with something which is compatible with U-Space, for example, ADS-L or ADS-B, you will be most likely detected, because these drone operators, they do not want to hit any airplane there. So there is a potential for the GA pilots to get equipped, but we do not want to impose a mandate, because that would be a no-go for these communities. This would effectively mean that the burden again would be borne by only one segment without clear benefits. ADS-L, very briefly, ADS-L is a first proposal of information set that was developed solely for the purpose of U-Space conspicuousness initially. It was meant to be affordable, and it's very light in terms of protocol. It's a baseline for interoperable language. It relies solely on GN as a source, and it has initial elements of privacy and security. So you can be anonymous with unique identifier, and you can have also basic security aspects in there. So it allows for that. That's already in there for 2 years. Those two aspects, ADS-B out and ADS-L, are available today, and they are being deployed, as you will see on the last slide. One highlight on this slide is its options from aircraft perspective. So pilots can use which technology they use to be conspicuous in U-Space. It's not for the U-Space service provider to define, I'm accepting ADS-B or only ADS-L. That's important. ADS-L for mobile is still in development, and once it's mature enough, we will publish it, and then it will be a 6-month period to start implementing it in U-Space. And we make sure that U-Space, those which will be deployed, will be ready to absorb this technology. What is a work on progress? And this is one of the last slides I have. ADS-L was developed for U-Space, e-conspicuity. So you are conspicuous in U-Space. But issue 2, which went through the consultation process, and we received some 200 comments, overwhelmingly positive, with some cautious reservations here and there on the approach, contains 2 new elements I would like to highlight in this presentation. It's first time ever we are expanding this possibility, technical option for remote ID. We have heard yesterday that Wi-Fi, Bluetooth, the range is somehow limited for certain operations. 860 megahertz, the SRD 860 band has a much larger range than Wi-Fi or Bluetooth. So we want to offer the operators of drones and NAAs to voluntarily adopt ADS-L for remote identification. So there is a way how to transmit remote ID over SRD. It's exactly the same information as in the international standards. What we are defining is the way to transmit it over that spectrum. But for general aviation, there is also an important element in terms of better situational awareness. We have introduced in one specific channel opportunity, and when I speak we, it means industry mostly, with EASA being helpful. We have introduced uplink of traffic and weather and other information. What we are using is the UAT-like information, so there is no differentiation at application level compared to UAT international standard, so we are fully consistent there. What we have adapted is the spectrum aspects, so the packets which are transmitted are smaller because we are using different spectrum. So these are the two new things which should help to improve situational awareness for both drone operators and GA. And I'm concluding my presentation with some real examples, because many of you may think, is this a real? We are talking a lot for 2 years, 3 years now about ADSL, icon security. I just want to tell you there are real examples happening right now as we speak. Just a handful of examples. I will not dive into detail, but look at the collection of multiple technologies and using the cloud services to share the information today. There are many more. I'm aware of implementations in France, in the continental France, Belgium, Netherlands. I've heard about initial talks in Austria. So there are many more other projects where a GA community would like to benefit from icon security. They would like to receive the mobile telephony signals into the cockpit. They would like to receive weather information into the cockpit. So that's it. And I will conclude my presentation with one surprise slide for you. You may wish to know that we have EASA is participating and contributing to this ecosystem. We have our own station on top of this building. So whenever drone transmits remote ID or transmits FLARM or something, ADSB, it's collected and it's shared throughout the network. So we have complemented the gray area, the gap in the coverage of this network, and we have our own station on top, and we are experimenting with this, with it as we speak. Thank you very much. I've taken a lot of time. I apologize for that, but I wanted to be very clear, and I hand over to Stephane, who will guide you through the GNSS problems we have, and that's needed to be addressed as well. Thank you.
Thank you, Vladimir. And before to go to GNS, I would like to really thank you, Vladimir, and all the team working for the implementation of USpace. You have understood that was not the trigger, but all what is done is extremely useful to support the implementation. We are also looking for some synergies between network remote ID, and the topic has been brought yesterday by Parrot, to see how we can merge the surveillance systems and to have one single device able to enable transmission of information for manned aircraft and unmanned aircraft. So those also works are ongoing because we have some questions. And very happy to see that the things are incoming. So I have relatives living in La Réunion right there, so I propose to organize a meeting there and to see. We have our director and the French authorities, so we can discuss about GNSS issues. As you know, that's something, yeah. Still a huge latency. I will be short because we are providing inputs and we are looking on the issues from a US perspective, but per se, the GNS issues is managed by another team in EASA. And I have already produced a lot of work presenting the issues that manned aircraft and the airliners, for instance, are encountering, and working hard on how to mitigate the issues for the moment, and looking at the solutions that may be implemented in the future to make the whole system more resilient. So it will be very short. Some considerations that we want to give to you, because we also need your feedback to see how you could help us to develop some guidance to support drones operations and the USpace implementation. This is public information. You can look day by day what is the situation in Europe. You have a report on flight radar, and you can see what the situation is. So for yesterday, for instance, you can see that Finland, south of Finland, and Estonia was heavily impacted. So when I hear, for instance, that they want to have, or they are looking for USpace in over Helsinki, those considerations, what about the disarmament of GNSS, what are the safety replication of those disarmaments on the operations, will have to be taken into account at some point. And you can see also part of Poland and etc. So this information is available. We have better sources, more accurate, real-time almost, provided by some authoritative source or other sources like Eurocontrol. They are not yet public information to my knowledge. So what has been done today, or to date, by the agency, you will find the safety information bulletin that has been dated this summer in July. Yes, in July. Which already help to understand what are the consequences of those disturbances on the basic operations, meaning the airlines. You will identify, or there is a certain level of characterization that has been included, say, helping the crew to detect an issue and recognize the issue. Even more important, to understand that the various failures that they may encounter in their cockpit is due to GNSS jamming, spoofing, failure, malfunction. The problematic we have is that today, in order to maintain the operation or to maintain the safety of the operation, the crew have to revert, in most cases, to non-GNSS-based information and conventional radio nav-ed navigation and approach. In some areas, some antennas or infrastructure and means have been removed, so some points the operations had to be suspended. That's the case of TAR2 in Estonia, where we also meant to have a sandbox for U-Space. So I don't know exactly what is the status for the moment. I believe they removed, they reinstalled some antennas and they have resumed the operations. The problematic we have, it's very man-aircraft oriented with avionics, with system detecting or able to detect some issues. Humans in the loop in order to characterize the event and to take decision, and backup in terms of means in order to continue the execution of the flight. All those things are very unlikely to be implemented for drones and drones operator. We are primarily GNSS based. We don't have information feedback as a cockpit. So we are even more heavily impacted than the conventional manned traffic or manned operations. So for that, we need your support and we need to work on characterize what are the effects on the time of operations. Considering the diversity of the unmanned aircraft, the product, and the operations. Because if I take the example again of the drones that we saw yesterday, like Parrot and the others, I'm quite sure they are only GNSS based. You don't have air data, you don't have IRS, you don't have radio navigation means. On the other side of the spectrum, yes, we have drones that are operator, big drones. We have a drone for Frontex, I believe, quite big drones with all the alternate means of navigations. So we need to characterize, depending of the type of drones, the type of operation could be BVLOS, could be VLOS. Certainly, the effects will be quite different, and the mitigations to be provided need to be proportionate. So higher is the autonomy, higher the risk, and higher will be the mitigations. Potentially today leading to the cancellation of the mission. If the turbulence is that severe that the safety of the flight is definitely impaired or not guaranteed, it's better to not take off. For that, we try to provide, yes, preliminary high-level recommendation. I'm very cautious because that's the first time we are communicating and there are a lot of to discuss. We would like the ATM and ANS, and this is also already a request that is being done for the other SIB and generally requested to those service providers, but to monitor the situation. We have other means to detect a disturbance using MLAT, for instance, and comparing the information of the MLAT or those radars with the DSB out, and if there is a discrepancy, meaning that there is spoofing or jamming. So this information could be provided to the operators. The manufacturer to assess the effect of GNSS disturbance on their product, telling in such condition we could be resilient or not, to which extent we are resilient or not, what could be the effects on some automations, etc. And here we don't know all the products, so that's for the industry to help us to understand what could be done. For the operators, being the first organization, entity responsible for safety, to maintain their own awareness on the potential disturbance, provided they have also the information given to them, to develop contingencies, or specific contingencies to address the issue. So what supposed to do if, as a sudden, there is a disturbance, or if you start to feel that the drone is not answering to, as expected, to whatever the orders can be given. So could have specific contingencies before to go to an emergency situation and total loss of control. To plan and to take decision on the execution of the flight. As I say, better to not fly if there is an uncertainty on the safety. For that, I do an analogy, roughly analogy, a bit, easy, but it's like for weather. If you are in uncertainty on the weather condition and you feel that you may not be able to safely execute the mission, better is not to go there. Last but not least, the role of the competent authorities may be to be focused also on those type of issues. Maybe some already have some policies, maybe some already have some procedures in order to help the operators in such situation, and they may also have some condition on the approval that I will give for the operations. And I conclude on that, we are aiming to work on a SIB, certainly replicating what is already existing on the SIM for the other type of operations, but with a focus on the US as well, and to provide more effective, complete, and clear considerations to you and to the competent authorities. And that's the end of the presentation.
Thank you very much, Stephane and Vladimir. We have seen the Slido. There are a lot of questions, but we don't have time to take them because otherwise we will be very delayed in the whole program. Where I invite all the colleagues who have put the Slido questions, so we need to do a little bit extra work on these sessions because there is a lot of interest. So those of you around the table, so you can still discuss during the coffee break with them. We will take the Slido questions and answer them and send them back to everybody because the colleagues online cannot discuss with Vladimir and Stephane. So we really here take the action to take all the questions and answer them in the best possible way. Now we break in 2 sessions again, so from until 3 o'clock this afternoon. So for the colleagues on the WebEx, you need to disconnect from this WebEx if you want to join the sessions that take place in the rooms Alouette and Bright, and connect to the other WebEx, and then change again the Slido session. For the colleagues here, again, be mindful and apologies. For next time, we will improve the meeting room seating. The capacity in Alouette and Bright is very limited. Apologies, 50 people, and the other colleagues, we need to stand up. So, yeah, I'm sorry for that. We will try to improve that. Thank you very much. Enjoy the coffee break.
So we resume today the workshop sessions, and basically this is again, we are again in the format where we would like to have more interactive discussions with the experts in the room. And I will be moderating this first panel after the break. And we will be discussing the subject of BVLOS operations over high seas. I'm not the expert, I'm going to be just the moderator, but I've asked the 4 expert people to join me and in the discussion. And the people that you see around the table, those are the speakers. So we had some preparatory sessions with many other experts that are actually participating to the event from the different communities in order to identify all the critical topics and that are relevant for this domain. So I'll go in the order as they are sitting on the table. I start with my colleague Gerli. Gerli, she's a legal advisor in the Legal and Procurement Department at EASA, and before joining us, she has been working at the Estonian CAA and at the Estonian Parliament representative at the EU. So she will play the role of the defender of the law. Then we have Jörn Jäger. Jörn started, he had quite an interesting career between ATC and airports before moving to DFS, which is Deutsche Flugsicherung, so basically dealing with the development of UTM concepts and systems. Then he went to Volocopter, where he became head of airspace and vertiports. And back in 2024 at DFS to take care of the responsibility for developing a new regulation and implementations of US and EU space. He also supports the agency in many regulatory activities, dealing mainly with ATM, SEA, EU space and vertiports, and also ICAO and EUROCAE activities. Then we have Joanna Rieder from the CEA Norway, where she's working as an inspector for unmanned aviation since 2019. And she's also been involved in the development of drone regulations in Norway, and has been a member in the US technical advisory bodies, where she's an active member also of the LUC task force. And last but not least, sitting on the far side of the table, we have Harry Howe. Harry is a regulatory safety manager in Skyports, and he's basically in charge of preparing and submitting all the documents in support of the operation authorizations for US operations, including those that we are discussing today. And before joining Skyports, Harry worked in the unmanned aircraft office for the Hong Kong Civil Aviation Department. So this is the team of experts that today will discuss, with whom we will have the discussion. And without further ado, I think we'll give it a start. So there will be different phases. So first you will hear about the regulatory framework. Then you will hear about what's actually happening from the operator's perspective, and also the perspective of the authorities, how these kind of operations are actually managed. So that all these views will give you an idea of what are the current constraints and limitations under which these specific operations are being performed, and so that we'll try to discuss together one possible solution and to see actually whether this is a viable solution that could be used for the future. So, Gary? Yes, I trust you with this. Yes. No, you push to the right direction, because the receiver is in that direction. Yes. Well, I can do it for you.
Yes, don't give the remote to the lawyer.
Yes.
It never works. So good morning to everybody. I hope you have enjoyed the workshop yesterday and also the sessions already what you have had today. Lawyers are usually brought late to the game, so I'm very happy that today I actually have the chance to set the scene when it comes to the legal framework. You can actually put. And the first question of the slide is, what are the high seas? And one could think that given that ICAO is very soon celebrating its 80th anniversary, we should at least have the understanding what is considered as a high sea and what is the airspace over the high sea. But unfortunately, like usually when it comes to the law, the things are not always black and white. And if the audience would be the lawyers here today, I think we could only discuss this slide until the end of the day. But I'll try to simplify the matters. So the thing why sometimes there are legal disputes, what is considered at the high sea is that the reason for that is basically the high sea is the subject of two different legal regimes. On one hand, we have the air law that is coming from the Chicago Convention. And on the other hand, we also have the maritime law. You can actually keep the other slide, but it's okay. Maritime law. And because of these two different regimes, the legal regimes, sometimes there is a confusion. What is considered the high sea under the air law or the maritime law? As you can see on the slide, the maritime law divides the sea or the ocean into different sectors. And basically what is considered the high sea under the maritime law is only the area which starts beyond the exclusive economic zone, and for which none of the member states or the states will have the jurisdiction. So some, let's say, argue that all the other sectors, the states exercise certain jurisdiction, which also means that there are states that consider that airspace over those different maritime sectors is also considered as a territorial airspace. So this is kind of the considerations that are under the maritime law. Since we are the aviation people, I think we should base ourselves on the Chicago Convention. And commonly the Chicago Convention and the airspace is understood as the member state has the exclusive jurisdiction and the sovereignty over their territory, which is considered as a land area, and the territorial waters linked to that land area. And the length of the territorial airspace is then limited to 12 nautical miles of the territorial waters. So everything under the Chicago Convention or the air law which goes beyond 12 nautical miles is considered as a high sea and as such as the international airspace. So that's kind of, let's say, the set that we have, that we need to keep in mind that there are two different legal regimes. But under the Chicago Convention, everything that goes beyond 12 nautical miles should be understood as a international airspace over the high seas. Now we can move to the, thank you so much. So once we have settled the question, what is considered as a territorial airspace and what is considered as a international airspace, we can speak about what are the applicable regulations. And when it comes to the territorial airspace, the Chicago Convention lays out that every member state have the possibility to introduce its own rules. When we translate this now into the EU system, it basically means that because in the EU, the competence is given to the European Union, it's mainly the Commission who has the power then to establish the relevant rules in the domain of unmanned aircraft. And here we are mainly speaking of course, the main law is the basic regulation, and also then the implementing rules, mainly the rules of the air, SERA, and the regulation 2019-947, which then established the requirements for the unmanned aircraft operations in an open, specific, and certified category. And of course, these rules apply only for the civil aircraft, because under the let's say the basic regulation, we are only regulating the civil aircraft. Now, when we are moving to the international airspace over the high seas, the basic regulation do not apply because the Chicago Convention, namely the Article 12, says that the provision of the Chicago Convention and particularly Annex 2 is applicable. Again, it's applicable to the civil aircraft. However, we need to bear in mind that for the state aircrafts, the convention which take due regard the requirements of the ICAO in order to ensure the safety of the civil aircraft. So these are the, let's say, the frame of the regulations that, let's say, we need to consider. We can move on. So as said, Chicago Convention is applicable because it provides the definition for the pilotless aircraft, also mentioning that it should not be operated without the special authorization of the state. And the slide, mainly then highlights the most relevant provisions that are probably necessary to reflect when we have now the discussions that how, let's say, these operations over the high sea can be put or can be made available, taking into account the considerations of those articles. The rules of the air, which I already mentioned, that refers then to the Annex 2, but also the certificate of airworthiness, because the Chicago Convention mandates the aircraft involved in the international navigation to have the certificate of airworthiness. If people knowing the EU framework, we know that this is established in a way that is risk-based, and not all the aircraft are required to have their airworthiness certificate. So again, we need to see how this provision can be then made, can be used in order to facilitate the unmanned operations. And maybe here as well, that it's not exclusive list, because we can also have we need to maybe see the registration of the aircraft, which is also required by the Chicago Convention, all the documents carried on the board. So there are a number of articles that were drafted, let's say almost like 8 years ago, when the drafters of the convention probably really didn't have in mind or didn't really see the way, these kind of operations will develop as they are today. And the last slide from my side. So as I said, the Chicago Convention Convention Article 12 refers to the Annex 2, because Annex 2 the requirements in Annex 2 should be understood as the ones referred in Article 12. And namely the Appendix 4 is applicable to the unmanned aircraft, and here we have to again see how those requirements, whether those requirements are suitable, because the way they are drafted right now, again, they are requiring the certificate of airworthiness. The operator of the unmanned aircraft needs to be certified. There needs to be the remote pilot license, and if we look at those. If you look those requirements strictly, one could conclude that under the current framework that is available in Europe right now, these requirements are mainly suitable for the certified category, but not maybe so much for the less risky operations. And Annex 2, as we know, differently from all the other annexes of the Chicago Convention, the member states do not have the really flexibility to apply it differently, because the Article 38, which allows the member states to notify the differences, is not applicable to Annex 2. So from really like a legal point of view, maybe one conclusion that we can draw is that Annex 2 and the Chicago Convention doesn't really address the requirements for the unmanned aircraft operations in lower risk categories. And maybe the discussions that will develop it either is not only addressing it, but some can also argue, since there are no requirements, maybe whether these kind of operations are actually allowed under the current framework. But I leave that to my colleagues here to discuss that. So that would conclude, let's say, that the legal frame that we are operating, or that we have today. And then I think we need to see what are the solutions. Thank you.
Thank you very much, Kerli. Now we move to this second part. We will see a clear example of certain types of operations that are already taking place in Europe today. And Harry will tell us more on how these are being conducted and under which framework. Please.
Thank you, Kerli, for setting the scene. Skyport, we are one of the LUC holder in EU. We operate BVLOS above the high sea. We have been working with Norwegian energy firm Equinor, and we partner for trial electric drone delivery to oil rig in North Sea since last year. So we use highly automated cargo drone, fly more than 100 km, operating cargo delivery from Mondstadt to the Gulf area and through Troy. So, and we also do rig-to-rig operations. So these operations are above high sea. And this on-demand drone service, the pilot is actually located in remote ops centers. So we submit SORA applications to our parent NAA, and then go through cross-border applications on that. So in terms of the areas, we have a series of strategic deconflictions measures. We coordinate with all the local aviation stakeholders engaged, including ANSP, other aircraft operators, helicopters operators, and the emergency service helicopters as well. Make sure our UAS activity will not disturb their usual business. And we make sure, especially for emergency service aircraft, including search and rescues, national security, policing, and medical aid will not be affected due to our operations. In order to do that, in order to enhance the configuration, we also develop temporary operating instructions, or we call LOA, with the ANSP to make sure we get all the input from stakeholder and allowing all the operators and airspace users can share the airspace in a short notice and make sure they are notified as well. So we, for this particular use case, we issue NOTAM and put in AIP as well. So just to give you an overview about some BVLOS operation about high sea.
Thank you, Ari. If I well understand also the area, it's over international waters. So of course, the subject of the NOTAM is already over international waters, right?
Yeah, correct.
Okay. Thanks. Thank you. And then now we go to the authority that is authorizing this kind of operations, and Joanna will tell us more.
Yes, so I'm from the Norwegian CA, but we have had discussions before this panel, discussion also with the French colleagues and a little bit exchange with the Irish colleagues. So I'm trying to give the position not only of the Norwegian view, but also of a general view that is my impression NAAs around Europe have. And as Gerli already said, for us it's a problem that there's uncertainty about what can we do with operations above high seas. We do get applications from operators, sometimes not directly stating that they want to fly over high seas, but indirectly we know that they want to go there. Sometimes we get cross-border operations where they apply for flying over high seas, or LOC operators that have the certificate from another country, but inform us that they're going to fly there. So what do we do with those? And in Norway, especially with the oil platforms, we have had many applications or many operators that would be interested in flying there. And Skyports is just one example. And we do get critical questions also from countries outside of Europe, why operators are flying there. So we have had internal discussions and trying to get a clear position from our legal department. How do we interpret the ICAO rules on flying over high seas? And without going too much into the details, because I'm not a legal expert, the result is that we say currently the rules and the interpretation of the rules is not quite clear. There is ambiguity, and we need to decide what do we do until it's cleared up. And for us, the main priority must be that the operations are considered safe. And for this, we don't see that a certificate of airworthiness is always necessary. There are some reasons, especially when we are discussing with, for example, offshore helicopters, where they would like to have a certification to be sure that the data is correct. But we do not have that at the moment, so we need to go to other mitigations. The main argument why we can do this is that the rules from the ICAO convention should be put into a historical context and should be interpreted accordingly. So it's not only the written text in the rules, but also the historical context and the intention of the context, which should be that the operations are safe, that should be taken into account. And so the other question is how can we make this type of operations safe out in an airspace where we have limited control over who is operating. We do not have the same tools that we would have in, over land. But on the other hand, there are also other risks and maybe less risk than we have over land. And since the panel here is about BVLOS operations, in general, BVLOS operations can be very complicated when they are in uncontrolled airspace and we do not know who else is operating. For any type of BVLOS operation, we need to look at it as a case-by-case basis, see what type of mitigations are in place. Are they appropriate for the applicable airspace, for the other air traffic that is in the area? And we usually would require an analysis of this other type of air traffic that is around. How is the drone operator visible to other air traffic users, and how do they discover and avoid other air traffic users? And for example, danger areas can be one tool to inform other people about operations, but it's only one tool out of many. Yes, I think that's all for now. We'll get back to questions later.
Okay. Thank you very much, Anna, for bringing the perspective not only of Norway, but also a coordinated view from other European authorities that are looking into the same matter. And you highlighted very important points, so it's the interpretation, so the legal perspective, once again. Before we move on, so I wanted to give you an overview, an update of what's going on at ICAO with regard to this matter. ICAO is well aware of the problem, of the issue, and there is already a resolution back of the Air Navigation Conference, of the 13th Air Navigation Conference, which took place in 2018, so 6 years ago, which was recommending to develop a solution to enable states to authorize operations of non-certified UAS over the high seas. So basically very low altitude operations. So they already foresaw at that stage, aware of the actual constraints of the regulatory framework, they were looking for a solution on how to enable this kind of operation. So there is a work ongoing at ICAO level. You know that ICAO takes its time before to come up with something stable and consolidated between all states. But there is already a more detailed plan which has been laid out recently. It started already this year. So basically where they're looking into conducting an assessment and a gap analysis of the existing regulation and discuss initial proposals on how to develop a risk-based framework. You know that also at ICAO level, they have identified or they've classified the operations of drones based on the risk category, and they have a system. So our system is aligned, and that means that also at ICAO level, the operations are classified as low, medium, and high risk, as we do in Europe. And therefore, they're trying to find a solution which can fit the existing framework. The intention is next year to develop an interim policy, which will be made available to the member state. But this policy will have to be, let's say, agreed in the frame of an assembly resolution as an outcome, will be an outcome of the assembly resolution. And then the actual work on the update of the affected annexes will start only at a later stage. So this means that before we have something in place that can be used as a reference from ICAO, we need to find an interim solution that enables us to authorize, or the member states, to authorize these kind of operations in Europe. Now, let's try to summarize what the actual constraints that you have seen before coming up from the ICAO Annex 2 and the various appendixes. And let's see if we can find a solution that can be worked upon. So basically, if you look at the airspace above water, in particular above high seas, and we look it from the side, we know that we can find different actors and different type of aircraft that are flying in accordance to certain rules. So rules that are conducted in visual flight with the VFR, with the visual flight rules. They cannot take place for altitudes below 500 feet. And flights that are conducted in accordance with the IFR rules, they can be conducted at a height above 1,000 feet. So it means that there is a bandwidth that, in theory, it's not used by anybody, but there is somebody that may be using this altitude band, and there are the state aircraft, so military aircraft, or the aircraft performing EMS operation, because they are not required to comply with the provisions of the Annex 2. So, which means, so the picture as it is today, this means that there is in theory an altitude band which could be used for our purposes, so to enable low-scale, low-level operations of drones. Nevertheless, we should consider some coordination mechanism to make sure that when this altitude band is going to be used by those actors that are not meant to comply with Annex 2, we are capable of establishing a two-way communication, or at least to inform them, so that we can make, in brackets, make space for them to fly their own mission. This is from the side, so the airspace above water from the side, but if we look at a European level, how it looks like from the top, and we see that the entire European region is separated in different flight information regions in the lower airspace, which means that there are certain service providers that are providing a series of services to enable the flights in a certain altitude band. And those are the ones, in theory, that we could use to as entities through which we could coordinate the activities that we have in mind. So this is the overall perspective. Now let's try to look at a solution, well, an equation more than a solution. Let's see if this equation has a solution. And so this is always have fun being an engineer as a background. I always have fun talking to legal, because being an engineer is either black or white, and when you talk to legal, it can be the 50 shades of gray. So it's a matter of finding a good compromise in an agreed way. So we said, okay, how the solution could work? We have certain provisions that are existing already in the European regulation when it comes to the drones regulation, so 945, 947, and in particular, the specific operational risk assessment, which is driving certain, which is, you're familiar with that, it is driving how to operate, how to conduct operation on drones. Then additional elements of the equation could be the assuring a coordination mechanism with an appropriate ATS authority, so an authority that is providing air traffic services, and this in brackets to comply with the provisions of the Appendix 4 of the Annex 2 of ICAO, which is defining the general operating rules for the IC's operations. Another element of this equation would be the creation of a dedicated NOTAM with the establishment possibly of a dangerous area or a restricted area over high seas. But now there is one important piece of information that we want to get rid of, and is the need of having a certificate of airworthiness, an AOC, a remote pilot license, in order to conduct this kind of operations over seas. What does this mean? Can we do that? So what is the equivalent context where in Europe, in European regulation, we don't need these elements when we are operating in the specific category? Because you don't need a COA, you don't need an AOC, you don't need a remote pilot license. And the next question is, do really the drones need to comply with the flight rules in an altitude bandwidth where there is no actual flight rules prescribed? So can we take the opportunity, seize the opportunity of the fact that there is an altitude bandwidth where no rules are prescribed? So trying to squeeze through the lines of the regulation. And actually, this is the overall equation that we have in mind how we could authorize this kind of operation. So taking benefits of all of these 4 elements on the top, getting rid of the additional other, let's say, provisions that are coming from the ICAO framework, on the basis that we have a shared understanding how to apply the existing provisions for that specific altitude bandwidth. And that could be one way of authorizing operations. So low scale, meaning one operator at a time, possibly, in close coordination with the ATS authority, which is responsible in the area, and low altitude operations. So this would be the European interim solution that we might possibly agree upon, and that could serve as a guidelines to member states to authorize these kind of operations. And I will leave this slide here because this is actually the content that we would like to discuss together. And I would like to start with Jörn first, trying to see. So first, I have an impression of from the ATS authority perspective. So, how do you see this solution? Is it the only one that we may have? And how do you see the risk assessment methodology? Is it sufficient to perform these kind of operations, or do we need to consider additional elements?
Okay. Good. I'm happy to answer that question from my perspective, and I have also to say that we had a discussion in a smaller group before, so I also try to represent the results that we have discussed specifically with colleagues from Eurocontrol. Yeah, I would focus specifically on that point of Appendix 4 because that addresses ATC authorities, which I consider is what we can maybe best address here from my perspective. I think first of all, and I think it was made very clear from the legal framework, we have to stick to ICAO Annex 2, so that applies. So there are certainly things that are not so clear that have to be solved, but not on a legal perspective, or on a legal perspective first. Let's put it this way. But when it comes to an ANSP perspective, I think what is the role of the ANSP in that airspace? Is there any responsibility at all? What kind of services are provided? And looking to the lower airspace, below 500 feet, I think there's rarely ANSP involved in terms of controlled airspace. Nevertheless, there's FIS service or could be provided. So from that perspective, I think, and I think it's an example that is used in the UK, if there was, for example, a TMZ, a transponder mandatory zone, that could be one way that drones are visible and are forced to be visible in order also for other airspace users to have a kind of safe operations. On the other hand, if you look to the Appendix 2 and what is also maybe provided there, it's radio two-way communication. So if they are aircraft and they are subject to FIS services, then they could be informed by an ANSP about traffic that is ongoing there. So that might be maybe a few aspects to that. I cannot say the question it's the only solution. I think there are several. Maybe one more word to NOTAMs. I think that's also something that is used today because it's a vehicle that is there and in place. Is it the right one? I would put a question mark here. I think first of all, we need to see also from the risk assessment, what is the use of an OTAM? So is it really helping, or is it just something that is generated but nobody reads it? So I think we have to see who needs to have the information about the operation. And if that is answered, then we can look what is the best means to communicate that. And I would consider that maybe we find something else than NOTAM that is more familiar and reachable also for the drone community, because we have these drone operations ongoing there, so they need to be informed about that. NOTAM is sometimes a process where it's not clear when a NOTAM has to be published or not. I think we also see that already today, that we get a lot of applications, but from the perspective of an ANSP is not necessary. And maybe a last word, danger areas might be a thing that was mentioned already as one thing that is allowed to do under current legislation. However, also that one, depending also on the period, how long the operation is done, might be something that may work in one case, but not so much in the other one. So also to see what is the role and the chain of people involved in that, or authorities sometimes, or in the case of Germany, it's not the ANSP who activate these kind of airspace. It has a process behind, which is maybe not helping really the enabling of that operation. So that maybe my answer to that in a nutshell.
Thank you.
Thanks.
Thank you, Jörn. I have another question for maybe for Harry. How can you explain your experience? How have you organized the responsibility of the different stakeholders for the specific when you were thinking your operations? How did you allocate the different responsibilities?
Thank you, Giuseppe. I think this is a good question. How to identify the stakeholder and understand what they need. I think, first of all, we will reach out to our parent NAA, and we will reach out to the local NAA as well to make sure those stakeholder that we identify is sufficient. And then we will organize a range of meeting and make sure their input is incorporated in the temporary operating instruction that we propose. So within that, we will propose what is our holding pattern, how are we going to do the protocol when there's emergency service need during the operation. So all these procedures has been in place before we have that meetings, and then make sure everyone is on board.
Okay, thank you. And maybe hooking up on this question, I would like to ask both you, Jörn, and Joanna, how do you envision the coordination mechanism between stakeholders? So we acknowledge the fact that there must be we need to ensure certain coordination, but how do you envision that, and what means we can use to ensure that the whole chain between the operators and the NAA and the ATS entities and maybe others are taken into account? Who wants to start first?
I'm not sure if I have one answer. I think the approach that Harry already said, have a meeting with as many as already in the identified stakeholders quite early in the process is very helpful. So everyone knows about the operation and can come with their input early in the process. I think it's always a challenge, regardless now if it's a high seas operations or not. Yes, maybe I stop here first. I'll see.
I'm not sure I can add much to it. I think I would more also refer to the principles.
Take the mic.
Oh, sorry. Yes. Sorry. I hope
for the people online.
All right. Yeah. Sorry. I think what is in general necessary, that the information is where it needs to be in the right format and the way that the pilots are usually also flying and needing that information, receive it in a way. So I think whatever we can do in order to inform the pilots or the flying community, airspace users in that airspace should be done. Maybe we have some tools available, and there are some first also tools that allow specifically also other users of that airspace, drone operators, to use this information like UTM systems or others, which are of course not certified. We know that, but it is helping, and we have already seen also in other presentation this morning that there are technologies developing that may help practically the airspace users to have that information. Does it have to be dedicated? I don't know. I mean, introducing a new means of information is always a bit tricky, but if it's useful for the community, why not? And yeah, I think I don't have the final answer to that. So I think that's maybe also the question, to what extent other pilots, specifically of manned aircraft, general aviation, need to have all this information. I think that's always to find a balance between too much information, and then pilots may not longer look to it. I mean, we see that also with NOTAMs. You can publish a NOTAM, but are we sure everybody's reading it? So is it the right way? Because if you receive every day 20 NOTAMs, you may not consider them relevant anymore. So we have to make sure that there's not an overflow of information, but at the same time, not losing any information. So yeah, sorry, I can't be more specific on that one, but that would be my view on that.
Thank you. And I would like to stay on the technology side, because you mentioned before quickly the need of being conspicuous to the other traffic. But do you see also other essential enabling technologies? And maybe this is a question for Harry and also for you, Jörg, in terms of what needs to be installed on the aircraft in order to fly these kind of missions the way we are envisioning those. I was thinking, for instance, how to measure the altitude, how we can share a common altitude system between all the players over the area, for instance.
Yeah, for our case, our aircraft installed with ADFC in and out. So it's just to enhance the situation of the pilot. I will stress on the strategic mitigations, that the coordination that we made with other operators in the area is a lot. And then on top of that, we have the ADSB out and ADSB in, providing the situational awareness.
Right. Yeah, maybe I have to disappoint you a bit. I'm not sure that the ANSP is the right party to define technologies. But I would say, from my perspective, I think from the perspective, it's not less relevant. It has to be sure that this technology really fits the purpose. It should not disturb other airspace users, and should be then available. And of course, it's, I think, mainly the users that you have to accept that technologies. We have a discussion with general aviation, equipage of transponders and all of the rest of it. So I think the drones that are operated need to be able to actually adopt this technology. So again, I wouldn't say this is the technology that has to be implemented. We know, and we have seen from the discussion before, there's certain limitations with frequencies for certain technologies, things like that. We have weight issues, we have certification issues, but this is not up to the ANSP to decide, but it is something then we just integrate. Maybe just a word of caution, which is quite obvious over high seas. There might be limited ground infrastructure, so we need to, I think, have infrastructure or technologies that less depend on ground-based systems. And of course, we have to see also in the current situation, what about regions where GNSS is not available or it's somehow limited, so that we make sure that the position and all what associated with that is still safe. So again, no clear answer from my side, but that would be my reflections on that question.
Thank you. And before we move to Slido, I have also another question which I would like the panel to discuss. I mean, this is more on the industry side. So all of us around the table, we acknowledge that this type of this type of solution that we are envisioning to this equation will bring a series of operational limitations in general to the whole community. But what do you see as a next evolution? So what kind of other business cases we as regulators should be looking at in order to enable to expand, to have this solution grow in the future?
Maybe I'll take with this one. I think this equation could be one of the equations to solve the issues. And in terms of operations below 500 feet, I would say some high sea area could be very low traffic, like within a few years, that's only 2 helicopter traffic. So we look at the historical data and compile SORA. I would say the best will be all these elements is good to have, and like Jon said, NOTAM might not be needed in some of the cases. And one more thing about the altitude, if it's above 500 feet, if under SORA, the operator could prove that it's actually safe to operate and get approved the SORA, and that 500 feet limitation could not be a hard limitation, I would say. Because I would foresee in high sea environment, there's some access is actually like wind turbine and so on, and then there's the cases that might be slightly that we might need to fly higher than 500 feet. But I think not to go to specific cases, but I think the 500 feet is a reference. But I think the major thing is the SORA applications and the coordination with the ANSP. For the NOTAM, it will based on that coordinated process and see if it's necessary.
Okay, and maybe very last question before we go to Slido is for Gerli, because I want to hear the lawyer again. And how do you see, I mean, if this group comes up with a solution to this equation, How do you see it to evolve into the future? Should it go into a regulation, into an AMC? Should we just publish some guidance, being aware of all the constraints that we have already today?
Thank you so much, Giuseppe. I have no doubt that you will come up with a solution. From the legal point of view, it's indeed a question that how it can be enforced, knowing that the constraints that we have, mainly the applicability of the basic regulation. This needs to be seen. I know that we have been discussing in the House whether we can develop the AMC material. I don't want to say no here at the table, but I think we need to keep in mind that the purpose of the AMCs, which are mainly the tools to facilitate the application of the basic regulation, and then it's the question if the basic regulation doesn't really apply on the operation over the ICs, whether this is the right tool or not. This needs to be still seen, but it doesn't mean that we don't have the possibility to, let's say, develop some sort of guidance. But I believe that whatever we come up, whatever it's the solution, I don't think it can be done in isolation from ICAO because they have the role there and also together with the member states. So I'm sure there is a solution, and once there is a solution, I'm also sure that there will be a way how to implement that.
Thank you, Kelly. And maybe we can move to Slido so we can take some questions from the audience. I've seen that there is a lot of quite some activities online. And yes, so this is the first, Alberto, this is the other panel. We need to change room, yes. Good. Okay, so we start from the top. We take it from the most voted. So the first question is, besides addressing the risk, how is the surface risk considered? Are there any flying restrictions over or near non-collaborative boats? If so, would video-based detection acceptable to maintain appropriate safety distances? Jörg, or can you take this? Or Joanna, up to you.
Yes, I mean, every operator needs to do a SORA, and ground risk is part of a SORA, even though the ground here would be the sea. It depends, of course, how much is known about the boat traffic there, how much can be addressed in advance. But I would say video-based detection is one appropriate mean, but it depends on the situation, it depends on the type of operation, type of system that is flown. So it's difficult to give a general answer, but it would be one mean.
You would like to?
Yeah, from my perspective,
yes.
I think typically the ANSP is looking more to the air risk, and this is what we also support in JAROS, and I think that's a question that we can maybe also place there a bit. So for more personal opinion, yes, I see there's a need of also having the ground risk in mind, also with ships being quite tall, 50 meters and more, so then we come easily also close to that 500 feet maybe problem of certain separation. But this is, yeah, more or less my personal opinion here. So I think what you said, Joanna, is quite right and should be looked at.
Maybe this will be an input for future discussions of this working group on developing a solution. Then maybe we can go to the next, which looks like a little bit more from the legal perspective, or because what is EASA's proposal to solve disputes between member states, CAAs, ANSPs over jurisdiction. For example, one CAA NSP blocking drone flights in their fighting for major region over an extended economic zones of other member states. Kelly, I'm looking at you. If we can take this on board, or we can think about it, because it's many legal questions. They are cannot be answered straightforwardly. Needs to be well thought of.
Yes, Giuseppe, you have learned well.
Yes.
Indeed, I don't think we can provide a reply here, because I mean ultimately it's up to the competent authority and the organizations under their oversight. You know how they, let's say, deal with those issues. I mean, of course, if sometimes EASA can facilitate the discussions, and I think I wouldn't say that it would help to dispute to solve the dispute, but I think if the more we have the common understanding how the rules should be applied, I mean probably this would also help not to have this kind of disputes. But EASA do not have the role of dissolving disputes between the member state and the organizations. But I mean, we can always, you know, I mean, what we always very often do is to provide maybe our understanding how the, let's say, the rules should be applied. But it also comes to the EASA basic regulation and the implementing rules. We really, for example, cannot really say how the member states are applying, for example, the Chicago Convention and the annexes, because it's ultimately the responsibility of the member state. So.
Thank you, Kelly. It's always fascinating talking to lawyer, to legal. There's another question which is ramping up in the favorites. It's this one is, for instance, a wind turbine located in IC somehow assumed being an atypical airspace. I think we're referring here to wind turbine farms. And honestly, I'm not familiar with the notion of atypical airspace, but maybe Jörg, you have any idea, or Joanna?
Yes, I think this is a Sora question. We have had questions similar for oil platforms and flames over the oil platforms, if it's a typical airspace there. I don't remember the answer though. It depends on the distance you have. I think in general, I would not say it's a typical airspace because you're never flying directly within the wind turbine. You always have some distance. And like Harry said, there's even the wish to fly higher above the wind turbines than you would usually allow. So in general, I would say no, but it depends on the distances you're thinking of.
Yeah, I think this is a good question for us. I think if we can prove the traffic is similar to atypical airspace, meaning we foresee there's very minimal air traffic in that area with the wind farm area, which normally is the case, then I think it should be part of the SORA for the operators to show this is atypical airspace.
Thank you. So we have another question, which is, we can take another one, which is the following. In the Skyport's operations in Norway, how much human effort and surveillance is still required for the current ops? What are the concrete standard procedures developed? Can you elaborate or explain a little bit more in details? Joanna and Harry, who wants to answer?
I think in terms of human effort, because the pilot is actually located in Bergen, which is our remote ops center, ROC. So that is actually helping because the pilot do not need to be on site. Second thing is when for this particular case, we work with our partner, the helideck landing officer, the HLO, for example, in the oil rig, they're very experienced in terms of having the helicopter to land and depart. So, and also we do provide hub operator training for the HLO. So to minimize the whole deployment. But I would say we have training effort before the operation. But after that, the human effort is kind of minimum. Concrete standard procedure developed. So this is a good question. We throughout these 2 years, we have been operating and we do formulate some procedures and in order for deconfection, in order to deal with some emergency situation as well.
Thank you, Harry. And maybe, Joanna, you want to complement for your aspects? No. Good. Then maybe we take the last one, which is, I think is going to be for Jörg, and I was expecting this question. And would detect and avoid become a requirement for VFR operation of a US in BVLOS? We could have an entire workshop on this, yes?
Yeah, I think DAA in general is quite the key to unlock operations, BVLOS in operations with a kind of integrated airspace. So again, not sure I'm the right one to answer that question, and definitely not when it comes to regulations here. But I think definitely we would need to have the DAA capability. That would help a lot, should become a requirement. And I mean, just reading the question again, VFR operation of a US in BVLOS, that in itself is somehow
contradictory, yes.
Needs to be clarified. Let's try to be neutral on that one. But I think when it comes to flight rules, and I think it was mentioned before, we have to be clear what is BVLOS operation of UAS if ICAO subs apply, Annex 2, so it's an IFR, is it a VFR? So I think this is a big issue we need not to forget. Yeah, so that may be just my immediate thoughts on this question, but happy to hear other opinions here in the audience.
Well, I think the time is running out. I would like to take one last minute, Alberto, if we can come back to the last slide, just to make a short recap. So I think that, I hope that now after this hour of discussion, you have a better understanding of how we, let's say, elaborated the equation. I think we had discussed also sufficiently enough, well, at least we had a good start of discussion of whether this equation could bring a solution that could be rapidly implemented in the EASA member states in the near future. This panel, or the experts that contributed to the setup of this discussion, we continue to work after this workshop to try to assemble together at least some main points or headings. Okay. And we will come back to you in the next months. But thank you very much for your interventions and your support to the panelists and also the people that contributed from remote. Thank you. David. Oh, okay, David wants to answer very last minute, so we have.
Yes. Thank you very much. I would like to.
David was part of the.
Yeah, I heard the session with my colleagues. I would like to stress some points. First, I would like to stress the need for a clear and shared understanding of the legal frame of the topic. That's for sure what is expected from a member state and a national aviation authority. I would like also to stress one point. By speaking on behalf of the operators, somehow, it's just to stress the fact that most of the operations are expected above 1,000 feet, because, for instance, you have some missions of surveillance of the sea that could be up to 5,000 feet, and this has to be taken into account. And also, I think that any tool such as transponder mandatory zone or USSP is worth analyzing, and also to which extent could we, as a member state, put in place a TMZ beyond 12 nautical miles. That's a point I think is worth also analyzing, because this tool could help us a lot. Thank you. Sorry for the extra time I took.
That was good, valid remarks that were worth to listen to. So those would be, again, once again, inputs that we will consider to our future work. And thank you very much. Now I think it's over. I think we can break for lunch, and we see again at 1 o'clock.
To welcome our panelists. Today, starting with Bobby Healy. Bobby is founder and CEO of Mana Drone Delivery, a drone delivery company which have an impressive record of operations in Ireland with several thousand flight hours last year. So welcome. Nice applause for Bobby, please. All right, the next in line is Thomas Neubauer. He is founder and CEO of Demeter, a company bringing together mobile network providers and drone operators to enable BVLOS operations, and he's also a board member of the Global UTM Association. Please welcome Thomas Neubauer. And last but not least, Antonio Marchetto, Senior Policy Officer from EASA, and amongst other things, he's in charge of developing the means of compliances for sales through operations in the specific category. Welcome, Antonio. All right, so as this should be a workshop, we're very keen on interacting with you actually. So I try to keep the introduction as short as anyhow possible, and we'll just set the scene that we're all on the same page and then initiate the discussions, and we're very happy to receive your feedback on this topic. So I already learned that this can be tricky. Oh, it works. So workshop title is Enabling C2 Link Using Mobile Network Technology. So our goals for today are first to understand how mobile network technology can actually be used as a UAS C2 link. It's already done today, so we have some experience with it. And we want to analyze the challenges to ensure safe operations. Just to set the scene, when we're talking about UAS C2 links, and we want to enable beyond visual line of sight operations, we soon run into the issue of providing an adequate command and control link. You're probably aware that radio line of sight has a pretty limited range, and when we're actually talking about long-range BVLOS operations, we need to make sure that we have adequate communication and control over the drone at all times. And this is not a trivial thing because, well, you could go in the direction and enhance your radio line of sight link, but this is pretty complicated and not possible in every state. Military relies, for example, on satellite communication, but this is pretty expensive and the data rates are rather low. So when you're operating in low-level airspace, mobile network technology could come in handy. We've already heard this morning that it can also be used, for example, for eye conspicuity, but using it as a data link is certainly one of the aspects to be considered. And we're aware that several different standardization organizations are working on C2 links. It's already used today, and in the safety analysis, in the specific category, there's also a dedicated operational safety objective dealing with a service level agreement. Because what makes it interesting from a regulatory perspective is that usually we're directly talking to the operator, and the operator is in charge of then, for example, providing the 2.4 gigahertz link or whatsoever, but it's located at the operator. And now when we're talking about mobile network technology, a different player comes into the game. So we need to also talk to mobile network providers, because drone operators, of course, have to rely on their services for safe operations. And this, gives us a whole new perspective on the topic. And our goal is really to understand, is there need that we provide new AMC guidance material for safe data links using LTE or 5G technology? Can we use existing standards? What are the expectations of drone operators? What are the expectations also of mobile network technology providers? Also in terms of providing feasible business cases, because obviously these services won't be for free. So we need to make sure that we also have all parties on board in terms of their business models. So just to kick off with a few experience, I'd like to first ask Bobby. You're using LTE communications for your operations in Ireland. Could you talk us through what exactly your company does in Ireland and how you're using mobile network technology?
Sure. So we are a delivery company.
Yeah, you need to turn on your microphone, I think.
Big on button, is it? Oh, yeah.
That's
good. My first time in front of a microphone, sorry. So we're a delivery company. We do short range delivery, so 5 kilometer radius BVLOS operation in Dublin and Texas, and delivering everything: hamburgers, coffee, ice cream, all the critical goods, saving lives. And we use LTE for our C2 link. Yeah, we use dual LTE connections, 2 different SIM cards, 2 different modems to 2 separate operators with 2 separate network stacks. So complete duplication of the stack. And we've been doing that for 3.5 years now. We've done about 250,000 flights now. So collected a lot of data in 6 separate operations. So seen a lot of masts. We've seen a lot of different behaviors from different networks under different conditions. So a lot of data to talk about, which you probably, for those that know me, you'll see that we share a lot of this in public. We share nearly everything about our operation in public to help the industry move forward. So I'm looking forward to the conversation today, actually.
Thank you very much, Bobby. So when regulators hear about new technology, we have this reflex of always asking, okay, that sounds interesting, but you now need to prove that it's safe. So obviously the network mobile providers will come into the game. So Thomas, what services and assurances maybe can also communication service providers actually provide to the drone industry? And is there a strategy in place also to interact with the aviation regulatory bodies?
multiple questions. So I think first, a couple of years ago, we were at the situation that cellular was actually considered a safety risk in aviation. Switch off your mobile phone, it's a safety risk, right? Now we're in a situation where cellular is providing a critical communication for safety in aviation. So it has been quite a spin. And actually, I've been sort of born and raised in telecoms. And over the last years, over the last 8 years, I've actually made the connection to aviation. And aviation asks for actually a lot of data that apparently cellular can provide. And I'm not sure if we have...
you have the slides.
So we have a very interesting study, a task force that was actually started by GUTMA, the Global UTM Association. It's a public report. I'm not sure, I think the slides will be shared, so there's a direct link to this report. And if you press once more, you see a little bit more. So the key question, thank you, the key question that was in the task force is, what is the demand from drone operators towards telecom infrastructure? And so the demand is here shown as blue, as there are several categories. Command and control is one, but there's also others. The delivery of what can be done, how the telecoms are providing that supply, is actually shown here on the left-hand side in sort of orange. And the obvious one is to provide connectivity. So to provide a SIM card that is allowed to provide services in the airspace, because that's not necessarily a given. And that is for critical communication and for non-critical communication. But, and that is important, there's also a wide range of additional services that are required by the drone operators. And obviously, drone operator is not exactly the same as drone operator. Some have other requirements as they do, depending on their operation. But what they have as an example is what is called here connectivity service volume. Essentially answers the question, where in the airspace do you have adequate connectivity? Which is, for everybody involved in SORA, it's the OSO 13 consideration. Do you have adequate connectivity in the airspace? So providing information about that is something that telcos can do. Or population density information, dynamic population density information. Well, static is provided free of charge, right? Who in the audience is registered in the political district here in Cologne?
At least
one. We probably have 0.8% of the audience being represented by census data. So it's not really representative, right? So dynamic data, the telco providers here, however, know that you're here. And they also know that you're right now sheltered. So that information provided from telecom information is something that telcos do for the last 20 years. And so on. We heard about GNSS issues today. Cellular can also provide information about GNSS independent alternative positioning information because they know. And so that sort of information, how to transfer that into aviation systems, that is one of the things that I'm dealing with, and that sort of summarizes my intro. There are standardized, as you asked about standardization bodies. Well, between telecom and aviation, there's no standardization body in between. So what we did at Telco and what we did at GUTMA started something that is called Aerial Connectivity Joint Activity, lovely name, ACJA, about 6 years ago, when we started the standardization of interfaces that allow the exchange of that information in a completely harmonized and standardized way. And that is now becoming a global telecom standard. And that is the question, is that something that can now be used in aviation as an acceptable means of compliance? Because historically there was no, now there is. And so we are looking forward to see how that can help provide that information in future.
Yeah, thank you very much, Bobby. Excellent transfer to Antonio, speaking of regulation. So from EASA's perspective, knowing that there are different organizations already working on LTE communication, and exactly as Thomas said, we're right in the middle between telecommunication and aviation. Well, what is the EASA's perspective? What do we need to regulate, or what can we standardize when we're talking about mobile network connectivity for drones?
Thank you, Falk. I was thinking, and I would start considering that our regulation, as we well know, is operation-centric and operator-centric. So the responsibility is put first of all on the operator. Now, I think Thomas or Falk has mentioned OSO 13. OSO 13 is the operational safety objective on external services, which is part of the risk assessment that the operator has to perform. So OSO 13 is central to this discussion. You have to meet OSO 13 as an operator. Now, I wanted with this slide also to point out that all the links, not only to OSO 13, of external services in our regulation and through the SORA. Starting with OSO 5, I don't want to make a long story, but you may notice that in SORA 2.0, the external services were not captured under OSO 5. Instead, in the SORA 2.5 that will be adopted, we expect early next year, the external services are included now. So this changes something. We have been drafting means of compliance to OSO 5, and external services are almost also tackled there. Then comes another quite central operational safety objective and means of compliance regarding C2Link, OSO 6, so-called. We have drafted it, and in it, currently we have a small chapter dedicated to services when an external service is used. And it's currently not so much extended, and we are actually, let's say, waiting also this task force that we have recently established about LTE, use of LTE for drones in particular, but not only for C2Link, will provide some results in the next couple of months to improve, if possible, this part of the means of compliance. Then we can also consider OSO 24 on the qualification for environmental condition, because at the moment in which you have modems hosting the SIM and whatever is needed to establish the LTE connection on the drone, then they need to perform correctly at the environmental conditions which are planned for the operation, with the vibration provided caused by the drone, and whatever are the other environmental conditions in the envelope that is planned. All this said, and there is also a mention in OSO 23, but this is also regarding the operator beyond OSO 13. All this said, beyond our means of compliance, then as it has been mentioned, we have standardization organization like Eurocai, for example, working on standard for the use of LTE for C2Link. I am participating now and then to the working group, subgroup 3 of working group 105, which is developing MOPS for C2Link by cellular. There is a draft, it will have to be consulted, is slowly growing, let's say. And then there are guidelines, Thomas, I think, provided also by ACGA, your organization, which have been published and may also provide additional information. So we have a whole set of information which we need to make sense of and establish its coherence.
Thank you very much, Antonio. So what always comes to my mind, or when I talk to operators, which we do very frequently as a CAA, the question always pops up like, okay, but when there is no signal, what do I do? I know the feeling. I've lived here in this area quite a while. When I board a westbound train, I will probably lose my cell phone signal after leaving Cologne. So both to Bobby and Thomas, what are the strategies operators can put into place? Or Bobby, have you experienced loss of links and how to cope with such a...
I mean, we experience loss of links every 5 minutes. So it's just a reality. So your operation cannot use LTE or any form of radio signal as a critical safety function. And so for us, it's more about awareness and monitoring of the fleet while they're in the air. So we know where they are, we know what altitude they're at, we know a lot of data, a lot of telemetry about the aircraft, but there's very little we can do about it other than issue flight termination. So for us, the real safety critical reliance on comms is flight termination. Remote pilot induced flight termination. But nearly all of the decisions, I would say, 99.9% of the decisions are made on the aircraft on its own. So even when we deliver into a complex environment. So there might be people underneath the aircraft, there might be cars underneath the aircraft, there might be a tree that's grown. Like we're operating someplace over 2 years. Trees grow in 2 years, and suddenly an object that wasn't there 2 years ago is now there. So you have to, all the processing has to be on the edge, and therefore you don't need communications. And communications will only come into play for us anyway when flight termination is required, or tactical deconfliction becomes reality. But we're nowhere near tactical deconfliction yet as an industry. But that's when we really need to look hard at this, what I would say is the Swiss cheese model of comms. So our, we know the reliability of LTE. We know when it gets weak, when we change altitude, we see, tower switches, all these things. And you're relying on a third-party operator in the MNO that doesn't have an SLA at all for that connection. So therefore, it's a very easy decision for us. We can't rely on communications for safety.
Thank you. Thomas, please.
Yeah, I would like to add to that, because when we talk about communication, I think we need to be very careful what, generally speaking, in telecoms, we have 3 different components available for drones right now. Number 1, functionality that exists and is used. Typically, you may use a standard SIM card or an IoT SIM card that you put into a drone and then you fly. Well, there have been specific capabilities in functionality that is available but may not be used today, like ultra-low latency reliable communication services. So you need to specifically authenticate your SIM card to services up in the airspace. And that means that you have a higher prioritization. That means that you have a dedicated handling of performance counters and so on. And the third one really is capabilities that are not yet deployed, even though standardized in telecom networks. Like for 5G, we're talking 5G. The way it is deployed right now is not actually a huge difference to 4G, whereas the fancy stuff really is just being implemented. So something like network slicing and so on. So there's an additional set of telecom capabilities. And when it comes to, as I showed before in this picture, one other thing I wanted to emphasize is communication is really important for doing 2 things. It is there for assuring safety and for assuring revenue, because some of the business cases that are not in the delivery space, the key delivery is data. Right? That's what a drone can do. It can either deliver data from a sensor, or it can deliver goods, or sooner or later it will be delivering people. But that's about it. And delivering data is, from what we have seen, also a very important component for all the emergency services, for all the safety-related aspects. And for that, it is not only the C2 link, but also to have a reliable broadband link up in the air. And that is then a number of features are probably not enabled because you're using the wrong SIM card, like interference mitigation. Everybody who was at lunch break, well, you couldn't talk. And the reason was not that you didn't have signal. The reason was there was way too much signal out there. It's called interference. And the same thing happens when a drone is flying above cell tower height, which is almost always the case. And then you have visibility to so many cells, and you're collecting all this information that you actually don't want. So networks have the capability to mitigate that interference, but you need to have a dedicated airspace SIM card that authenticates the service that you're running on for that. not always deployed today. Some telcos already do. We even have people here in the room from Vodafone who actually provide such capabilities already today. But it's not widely available yet, but it's coming. And so I think it's because in standards, telecom standards, drones have been considered for more than 10 years in the standard with dedicated functionalities, but they have just not been turned on because, to Falk's point, show me the business. And then it's going to be, you know, it's a chicken and egg thing.
Thank you very much, Thomas. I think now's the time also to take questions from the audience. Maybe Alberto, you could put on Slido, and we maybe can also start just with a question from the audience here. Does anybody want to ask our speakers anything? Don't be shy. Really, nobody? I have a few more questions. David, please.
Thank you very much. Thank you for this presentation. I just wonder whether the level of sensitivity of the subject also depends on the level of cell we address. I mean, the constraint we could envisage on the way we will use this kind of technology could also depend upon the level of cell. If you have say a failure of your C2 link for cell 2, that's completely different than that of cell 4 or 5.
Maybe a question to Antonio. You were keen already.
Yes, okay. Thank you, David. Absolutely, yes. And we were discussing, in fact, Falk and I lately, regarding the OSO 13 and how it is worded. And it says basically that the operator needs to establish a service level agreement, an appropriate service level agreement, in case the service directly leads to a loss of control, which means that if that service fails, then you have a loss of control. Now, there are two questions now. To define exactly what is a loss of control, and the SORA gives definition, but sometimes you have also to interpret. And then establish if you are really losing the C2 link when you lose the service. So for simple architecture, let's say lower sale, low cost, simple architecture, you might perhaps imagine that in some cases you may not even redundant the service. You have one LTE provider. In that case, if you lose it, then you would lose control of the operation. You will have to have a service level agreement. Now, as you shift towards higher level products and sales, it should be expected that you don't have just one service and nothing which is redundant and could substitute to it, being it a second LTE, but we have also cases in which we have a SATCOM talking beyond radio line of sight, which can substitute the C2 link, of course, at a certain costs. And at the moment in which we would be in that situation, as long as the shift, the switch from one service, let's say to LTE to SATCOM, would be sufficiently smooth, then we could say that, okay, you are not in the situation of the OSO 13, in which you must show to the authority that you have a service level agreement. All this said, it is important, I think, to say that one thing is you need to show to the authority. The other thing is, well, in any case, remember that you as an operator are responsible, and it's not that the SORA is saying you that you should not have a service level agreement in that case. It's just that the authority is not asking it to you. But you as an operator continue to be responsible to decide what you need for a safe operation. And so perhaps you still need to establish a service level agreement.
Thank you very much, Antonio. Maybe we take the next question, which is the highest rated from Slido. there is a specific contract with service providers to guarantee a strong signal during the route. Is that contract will be available to serve as a mitigation for that authority? Maybe two questions at once. First, directed to Thomas. Is there something for as a guarantee from network providers that we always will have signal en route?
Well, what telcos will be providing is actually specific SLAs, as they do, in other services. But any commercial communication system is a best effort. So the question of redundancy, which is one of the other points, applies to what is the risk assessment. But there will always be some sort of SLAs that can be provided, and there will be a live conformance monitoring. So this is continuously actually like you are to report positioning information. You can actually from the network, you can continuously monitor the performance of the link up there. So there are specific functionalities out there that can be done today to assure that there is a certain level of performance given. The question is, how will authorities accept that? And that is currently subject of discussion. What is required? What are the operational considerations that need to be considered?
Thank you, Thomas. I think this is exactly also what the LTE task force, Antonio, is tackling to define how such a service level agreement may look like and what it's needed to be included. So, do you want to comment on any ideas already in EASA's mind what such a service level agreement would need to be included?
Actually, we have defined, if I well remember, an action for Thomas for the next meeting to bring to us some template or service level agreement. So
thank you.
We wait for the next meeting.
Excellently polite answer. All right. So there were some other questions from. Yes, exactly. There were another question from the floor.
Hi, Paul from Sweden, Air Forestry drone company lifting trees from the forest. Question to Bobby. You were talking about the flight termination, and you sometimes, I'm not sure if I heard you right, you're losing the C2 link continuously. Every 5 minutes you said something. How do you guarantee, or how does the authorities demand you to guarantee the flight termination?
Yeah, I mean, we all know how unreliable LTE is, and if you have two LTE connections across two separate, so our flights are 6 minutes flights, right, out and back quickly. We don't take off without a high quality connection on both modems to two separate operators. So if I look at our data, we have 3 or 4 nines of reliability on the cumulative result of having two LTE connections. And the latency, we send all C2 commands, including FTS, over both links concurrently, and we just use the least latent one. So it's a very simple architecture common in any network going back decades, and it works. Is there a time when we lose both LTE links at the same time? I haven't seen it yet, but I've seen it. For example, we have a test site in the middle of Ireland that's very rural. And so the two operators that we can see are very far away. The masts are far away. So when I refer to the every 5 minutes, it's on our test site. We wouldn't expect to see that in most of our operations are in high density suburban areas where there's a lot of masts there, and we're doing a lot of mass switching as we fly because there's just a better option that the network will choose. So we again, as I said, I've never seen a situation in our 3.5 years of operation in 6 different locations where we've been completely dark. But I've seen it slow down, but never slow down in a way that it would render the FTS unusable.
Thank you very much, Thomas. So we're taking the next question from Slido. Current network maps of providers show the availability on the ground. For flight applications, you need a 3D picture considering altitude. Are there any approaches to tackle this problem? I suspect, Thomas, you're the right person.
So the answer is yes. This is state of the art today, that we have 3-dimensional live pictures of airspace connectivity. I refer again here in the room, as DLR is here in Germany. There is commercial availability today of 3-dimensional live pictures of connectivity. And there was also a question on, how can you get that for a flight plan So to submit something for an event that happens in future, well, there's a lot of history in telecom networks, and there's also, patterns repeat, like, based on time of day, day of week, seasonality, and that data can actually and is actually stored within the telecom operators, both for the dynamic population density information as well as for connectivity. So you can project, you can forecast actually extremely accurately how things will perform given certain circumstances. And that is something like, typically it's looking 6 weeks ahead, can be longer, but that's what typically is done. And so the 3D picture is done today. And for that, we have in ACGA, we have actually defined dedicated APIs that are providing that information in a standardized manner. So that is the same across Europe, across the globe. And therefore, for a drone operator operating on this or the other side of the Atlantic, they can actually refer to the same interface specification, as this is now becoming a telecom standard to provide that three-dimensional information in a defined format that it can be provided. Compare it with wind and weather. It's a defined format, same with the telecom data in the airspace.
Thank you very much, Thomas. Any other question from the room? All right, then we continue with Slido. Question from Matthias. When using redundant LTE providers, how do you ensure that they really operate on independent or even dissimilar systems? Some cell phone providers roam on some other providers' systems. Many use the same hardware in terms of manufacturer, type, and make. Maybe that goes both to Bobby and Thomas. Have you made experience with this?
I'll quickly answer that. That hasn't been a problem for us. We know that we're connecting to a real rather than a virtual network. We know the mast identity. We know the ID and the location of every mast we're connected to. So that at least part of it is quite easy for us to make sure it works well.
For some of the larger aircraft, talking urban air mobility, we have actually, there are modems that do both terrestrial and satellite today. So there's also additional level of redundancy on that component. I think, as Bobby said, that is not really an issue.
Thank you very much. And what I would be keen on interesting is you said that we could ensure interoperability worldwide because it's a telecom standard. So Bobby, from an operator perspective, is this rather easy then, for example, to transfer your operation to Germany, France, whatsoever?
Yeah, I mean, we like I said, we're always going to be operating in high density suburban, which always has saturation of LTE availability. So we don't expect that to be a problem. When we look at all the cool stuff that's available with 5G, the network slicing, the quality of service, things like that, a company like us, we're commercially viable. We can't rely on any of those technologies because they're just not available in a consistent way across the world. But LTE is. So it's the lowest common denominator for us, which is LTE.
Thank you very much. Question regarding dynamic population density data. I see the advantage of having data that is more representative of reality than static data. However, the ground risk assessment is conducted earlier than the operation. Will there be any historical dynamic data available, and how will it be usable? I think that goes both to Thomas and also maybe to Antonio, how we can, as regulators, use historic data. But Thomas, please first.
So it should be mentioned that this population data for telcos is nothing new, right? It's in place for the last 20 years and used for the last 20 years to the highest extent, but just for different purposes, like ensuring quality of service and so on. But now it becomes interesting that you can actually provide that to an external service satisfying all the GDPR requirements. And that means you have certain requirements when it comes to how you are allowed to store some of the raw data. And, nobody's interested in where Thomas is. Well, not everybody at least. But aviation is only interested in the number of people for a certain area and is that person sheltered or not, plus some additional stuff. And that is sort of, that's sort of really just skimming the surface on that. And that data can actually be processed and stored for quite some time. We're working with some partners who stored it for 15 months or longer. And by that, you can actually easily determine, a beach is a great example, right? You may have a lot of people registered in the census data in their beach houses, but practically, they're not really there in winter. So that is something with the telecom data, you just have the seasonality on top of that. And that is something that can actually be processed and is made available.
Thomas, maybe, Antonio, what I'm currently now thinking about is that when we have all these data available, both for C2 link, for population density, they are put into very different places at the SORA. So we're talking about a service level agreement for C2 connectivity, but we maybe also need to think about a service level agreement for providing population density data, which might be counted as a critical service because it's determining the ground risk class. Would that be something to take on board for the LTE task force, or do you see it in another work for EASA, some other place?
In fact, thank you, Falk. I think we have two task forces actually, which involves LTE. One is what we call LTE task force, and is tackling the use of the C2 link, of the LTE for C2 link, to support the C2 link as an alternative source of position, and for iconspicuity, as we heard today, and other uses. The other task force, and I think Thomas participates in the other task force, is regarding the use for population density. And it is indeed taken over already by that task force. And regarding that specific question, regarding the fact, yes, they are dynamic, but then what do we do with real-time data? I think what we have in principle defined is the possibility, first of all, of semi-dynamic or semi-real-time data, which means that by means of the measurement carried out with the LTE, of population density in various interesting zones where the operation can be carried out. And let me say, historically accumulating data, then one would arrive to establish something realistic of how the population along the day and weeks and months, depending, the weekend or not the weekend, evolves in that zone. Finally, looking at the real-time data, but that would mean a full automation, let's say, probably of the authorization process also.
Can I add to that? Because we're a consumer product, we have about 8,000 of our users in one location that gives us their location every 15 minutes. So we have real-time data in the heat maps of where the population are, and you see all the things you would expect. We know when they're sheltered, obviously, but we also know where they are in groups. And bus stops are a big source of high-density locations. But if you have a consumer-facing product, you actually can get permission and collect aggregated anonymous data in real time. So all of our flights consider that data in real time already. Aggregated. Yeah. We aggregate it, it's anonymous, it's just a location ping every 15 minutes. But you can, it's a small sample, 8,000 out of 150,000 people that live in the location we serve in Dublin, but it's it's strongly representative. You can extrapolate from that and really safely conclude where the bodies of people are.
That's very interesting. And you had to have some permission to
yes,
collect all this data, right?
Of course, you have to. It's very GDPR sensitive, obviously. Obviously. But it works, and there's other companies have that. Any consumer-facing company can crowdsource that data if they have an app on the phone and they can get the customer's permission, and that's far better than I think the data I've seen coming out of mobile phone operators.
You have two questions on the floor.
Yes, please.
This one was my question, and I would like to add one part is that I understand all of this historical dynamic data can be used. And for example, for seasonality, it makes sense. But you also have a lot of events that are not predictable. For example, spontaneous demonstrations and these kind of events. even today, for example, you say these operators, they are aware of us being in this room and being sheltered. But 6 weeks ago, would they have been able to predict that? I don't know. But do you have quantitative studies that have actually compared this historical dynamic data with the static data or population census? And do we know how much better it is, how much more representative?
So it's always difficult to predict the unpredictable. With regard to if you don't know that some things will happen, you cannot really predict it. But for that reason, there's, and I got the example in Berlin, there are every year about 200 demonstrations that are not actually announced. So how to deal with that sort of thing? And the question is, what is the next best alternative? So with telco networks, you can get every 15 minutes, you can get actually a picture of what is going on. And that historically has not been deployed to anybody, or it has not been deployed to anybody at a reasonable price point, right? Because that is also another component, how to make this commercially available. From an interface perspective, we have been working on that for the last 6 years, we have defined it such that we can actually forecast that correctly, but also have a live interface where we can every 15 minutes provide an update if something is actually, causing some changes to the risk profile. So if you meet a certain threshold, then you're actually providing some information like a NOTAM on, hey, there is a bunch of people that are exceeding something that you have not considered. So the interface standards, they allow doing that, and the practical implementations are, it's a process. It's not happening everything overnight, but it's a process, and some have already started delivering on that.
So you could base your SORA on the historical dynamic data and then implement this kind of alerting system so that if we reach a value that is above a certain threshold, then you can know and you interrupt.
That is, as Antonio mentioned, that is currently under the discussion within EASA and the task force on what does it mean? How, for example, simple aspect, what's the granularity from a geographic resolution perspective? How many subscribers do you have to have by a telecom operator so that it becomes representable? Those sorts of questions are currently being clarified so that it can be used, because at the moment it cannot. And that is what we are trying to change to make it better than things that we have available in a standardized manner.
And the last little part, compared to static data, how do you consider those without phones, like all the children, for example? Because when you do a risk assessment, if you have a school, that's very important.
Yeah, that is there was a study by the German Statistisches Bundesamt, I think that's what it's called. So they have done analysis on how they can actually use mobile phone data in a long period of analysis to actually compare that with census data. How representative is mobile phone data for that? And all of the COVID situation actually helped, where they used mobile phone data a great deal to actually analyze the mobility of people. And there has been an enormous amount of studies on exactly that point, how representative it is. And you see that with one telecom operator, you get a reliability of more than 90%, and it goes up to 98% if you use the data of 2, because you have such a huge statistical sample. And that is then from that data, because they also have information about the demographics, about the subscribers. Without sharing that, they have internal processes to actually extrapolate that to the entire population.
Thank you, Thomas.
Very interesting. Thank you very much. There was another question in the room.
I don't want to ask a question. I want to complement a bit that. So we talk about the SORA and about the processes, how to assess that and how to somehow create a reliable service. So the Annex H of SORA is the one which is addressing that. So there is a service about the ground risk, and there is also the statement about how authority can assess the population data. And it's about the population data. Service provider will create a service about that. And depends, is it temporal data? We use the temporal data, not like a real-time data, because it's very problematic. So SORA Annex H will be released in 2 months. We'll address the need, what you just discussed.
Yep, thank you very much for this compliment. There's another question.
Thank you. I just wanted to jump in after Aurélie and want to develop the issue about using dynamic data, because last week we had in Austria a presentation by Kaiser with dynamic data, what you can do, and we discussed that currently SORA is not really prepared for this. But then we discussed also that SORA currently, you make your SORA weeks or months before you start, and so you normally use static data. But then we discussed how can we develop generic SORA, and generic SORA could be the key to use this data. I think Natale is not in the room. We should discuss with Natale if we can maybe implement more for developing dynamic SORA further using exactly this dynamic data. That is just my idea.
Thank you very much. I think this is really a good point, and I suspect Natale is really the right person to address. So I would like to jump back just once to Slido to keep it fair also for the online audience. The next highest voted question is LTE 5G link is supposed to be employed for BVLOS operations. In this case, FTS needs to be reached too. Having two dissimilar systems introduces an expensive complexity which by now is not taken into account. Would you accept a single RX box on the drone delivering both C2 link and FTS link? Antonio, is this something which we could press into MOC 2511?
Yeah, it sounds like reminding the MOC 2511, yes. But it's not that it is not possible, it is possible. If you do so, you do not comply to the means of compliance 2511, which we wrote as a simple recipe adequate for a declaration, where we have a segregated philosophy between the flight termination system and the drone. But this said, you don't comply with the 2511, but you still can comply with the requirement of the SORA, which is one step higher, in other ways, with proposing other means of compliance. And of course, usually what happens in that case, our experience is that we would have a DVR application, because if you cannot declare to the authority directly with the means of compliance that has been published, usually what happens is that a DVR can be open and your solution can be looked into during the DVR.
Thank you. Bobby, was that a challenge during your authorization and daily operation process when you have two LTE links and you also link your FTS through that?
No, it was pretty straightforward. It's an evidence-based approach we took, and it was relatively straightforward.
Thank you. And there was another question, please.
Yeah, quickly maybe, since we talk about mobile technologies, are there any considerations about using these mobile technologies on private networks so we don't have the telcos in between, so to speak?
So the answer is absolutely. I mean, if you look into campuses and others, and I take energy distribution networks as an example, many of them actually have 5G private network licenses. And it's just a question who operates the network, but the technology is exactly the same. And think about railway systems in future. The future railway system, communication system will be 5G based, and that is a safety dependent network. So without a doubt, they will look into that. But until that happens, commercially widely available networks are for sure the choice. But we see a lot of private networks as one of those capabilities that will be dedicated for certain applications without having all the interference that we experienced for lunch break.
Okay, thanks.
Thank you. We now put together also that we can do a lot of more stuff with LTE or mobile network connectivity, except for the C2 link. And coming back to mixing the data link with population density data, Bobby, would it be a possibility for your operation or bring you any advantage if you say you would modify your flights dynamically, choosing the right route to avoid people? Would that be an option, or would that bring you any benefit in the operation?
Well, that's what we do today. So we have a heat map on the ground in 10-meter hexagons, and every route that's calculated will use the population heat map to basically bias against flying over bodies of people. So that's what we do today.
All right, very interesting. Any questions from the room? Then there is one, of course, legal question. Is it legal in every EU member state to use mobile network for aviation purposes? I'm not an expert on this one, so I'm looking at Antonio. Can you answer this question?
Any lawyers in the room?
Any lawyers in the room? Yeah.
I cannot say to be an expert on this, but we are, first of all, we are talking of drones in the specific category. And so the fact is that depending on the member states, also depending on the zone of the operation, there could be interference especially at low, high operation at low altitude, with other kind of services and other operations. So I think eventually, I don't think there is a definite and final rule from the CEPT, which is the organism that has taken care of this topic, at least in Europe. But during the operational authorization, these are things that, in fact, according to OSO 6, should be looked into the frequency, the utilization of that frequency in that zone is acceptable.
If I may add to that, it goes to the telecom question on what are you allowed to do with a certain spectrum per country. And that is a question that, as mentioned by Antonio, the CEPT actually gave yes, these frequencies can be used in aviation, but spectrum handling is done on a national basis. So some countries make it dedicated that certain spectrum can only be used for terrestrial use. So they have to solve that problem. For example, in the UK, they solved it by providing a license for using the terrestrial spectrum in the airspace. And telcos go for that, and then it's all good. In other places, it's sort of a bit of a gray area, and other countries are actually now making that acceptable in a dedicated way. So making it legal is a process right now that is happening. And the simple point is there is a lack of alternatives that are commercially viable because cellular is existing, proven, widely available, cost effective, flights, low energy consumptions, So it's there, it's working. And getting all the other things sorted is a question of how to do it, not if you want to do it.
Thank you very much, Thomas. You can keep your microphone on because the next question is also for you. On the Show Me the Business comment, could you talk about examples where the mentioned advanced capabilities have yet been deployed? I suspect.
Right.
What the costs are?
I have to add to that different telcos are actually addressing the question in a different way. Some telcos are seeing that as providing infrastructure as a service. Some people just say, hey, we are selling a SIM card and you can then use it in the airspace. Others say we provide SIM card plus additional data. Others say we provide a platform as a service. SIM cards plus data plus even additional services like, flight management control systems. And even other telcos are actually becoming drone operators. One of the examples has been over the summer, Swisscom being probably the largest drone operator in Switzerland, becoming the largest drone operator in Switzerland. So they are doing that end to end. And then the question is, what is the business case? And for those who are providing infrastructure as a service, they typically bundle that with a dedicated SIM card to provide data on top of it. Because if you have a SIM card, you also want to know where it actually works. And on top of that, they are providing you some dynamic population data for that. And ultimately, it has to go down, in volume, certainly below €1 for a flight. So, but it depends on how the different subscription models ultimately work. But it's not, The business models are developing, but practically speaking, it's usually a bundle of different aspects to bring those things together and make it work because they have a viable interest to make it work.
Thank you, Thomas. I would like to hand that over also to Bobby because he has to know. He has a business case running with it. Your delivery fees, I looked it up, they are actually not very high. So is the LTE communication actually a factor or is it so low that it's...
It's very low. Yeah, it's not a factor.
It's not a factor. So we have maybe time for one last question, last chance for anybody in the room. Then we'll take one from the last one from Slido. For high sail operations, we need endorsement of radio network solutions which guarantee required C2 performance. What efforts are being made to encourage member states to regulate their national spectrum allocating 530 to 591 megahertz for aeronautical safety and UAS C2? Very interesting question. I'm looking at Antonio, but you're not looking.
Hard question. I wouldn't really know what to say exactly regarding the national spectrum allocating that band of frequency. And I asked for some help.
Thomas, is that something for you as well?
Yeah, we see that in some countries where we are operating. And the question is, so there is a dedicated spectrum that is allocated for airspace operation. That means you have to deliver a dedicated network. And that's going to be costly. So if you have an existing network working in the currently used frequency bands, it just comes at a lower cost. So for the short term, I don't see how this is commercially viable compared to the existing spectrum and the existing infrastructure that does that. And with 5G deployed on that existing spectrum, I expect that to be more viable because with, for example, a network slicing functionality in 5G, you can make the existing network behave like it would be a dedicated network. So building a dedicated network, always a great idea. I think the vendors will love it. But I don't know if that is in the short term a viable commercial option.
Thank you very much. And with that, I'm looking at the clock. Our time is up. Thank you very much for your attendance and the lively discussions. Special thanks to all our speakers, and thank you for participating.
Thank you very much, Falk, and all the panelists for bringing forward the challenges of these new technologies and what this new technology can bring to the drone world. There are indeed many interesting topics on which we need to follow up. So let's give 30 seconds for the people to decide whether they want to stay in this room or the next one. In the meantime, we can prepare for the next panel. So, colleagues, if you can take your seat again, we will give it a start to the next one. So the next panel will focus on the testing of drones, of US design and operations. And we look at how to find opportunities that are already foreseen by the current regulation for enabling a framework for testing of drones and trying the new operators procedures. So it's not really, for many of the sector, it looks like a catch-22 situation where you need to demonstrate something before you're able to test something. But in order to test something, you need to be able to demonstrate something. So let's see how we can sort out this dilemma. The panel will be moderated by Alberto Cunial. Alberto is a junior drones project manager working with us in the section. Alberto, the floor is yours.
Thank you, Giuseppe. So today I have the pleasure to moderate the panel, and with me we have Marten Bonema. He's a senior inspector from the ILT, from the Dutch CAA, with many years of experience in the UAS domain. We have Rocco Nannavecchia. He's manager novel technology fielding at Pipistrel, and is involved in the deployment of the Nuva drone. And we saw some details of this aircraft during the presentation yesterday. And then we have Daniel Salberg. He is a founding director of the National Experimental Test Center for UAS at DLR. And today he is representing not only DLR, but also the European UAS Test Center Alliance. So thank you for being in this panel. So the goal of this workshop will be to identify which are the possibilities that the current regulatory framework, as it is, allow to enable drone testing and allow to facilitate this kind of operations. So today, when an operator wants to try its use case, or a manufacturer wants to test and develop a new technology on their UAS, they need to start an operation in the case they want to do some flight testing. So they open our regulation. If the flight is to be conducted in the specific category, the risk assessment with SORA need to be carried out. The safety objectives need to be complied with. But then, reading through the safety objectives, especially for medium and high risk operation, the operators end up looking at this kind of provision, so that the who is applying for an operational authorization has some supporting evidence of compliance with the operational safety objectives, and this evidence can be achieved by testing or through operational experience. Other examples are that the applicant holds a recognized flight test organization, or that the adequacy of the procedures is proven through flight test. So during this workshop, we want to see how to make this sort of loop functioning. So if I want to test, I need to comply with this, but the test is an operation itself. And these are the requirements that apply. So how can we make it work? So for some cases, when the drone is below 25 kilos, if it can be operated BVLOS and below 120 meters, the test can be conducted in the open category. So this is a sort of reminder that this is always a possibility, and that in the case of a testing, the drone can be operated as a privately built drone, because it's operated by the manufacturer for its own use, for the purpose of testing. So no class mark is needed when operating in the A3. You need just to find a proper environment sufficiently far away from a residential area, and then the test can be conducted. Then we will see in all other cases. So when the test cannot be conducted in A3, how can we use our regulation? So we have involved in the operational authorization process. In the operation, we have the, let's say, usual actors, which are the drone operator, the drone designer, and the authorities. And then we will see during this workshop that for testing, we can open the door for a new actor, which are the test centers. And we will see how, which role they can play to allow this kind of operations. And also, I would like to highlight that having a network of test center, which is bringing together the civil and military world, is one of the flagship actions of the EU Drone Strategy 2.0. It was also mentioned yesterday by the Commission, the importance of having the collaboration between the civil and military worlds to allow to collaborate to allow testing, to support the development of new technology, to ensure that Europe can keep advancing and in the research of new use cases, new technologies. Okay, so this was the introduction to the topic, And then my first question will be to both Martin and Daniel, and taking up from these slides actually. So, can you share with us if you have like your experience a bit of coordinating with the military side? So maybe we can start with Martin and then we go on with Daniel.
Yeah, good. Thank you very much indeed for the introduction, and good afternoon, everybody. Yeah, we had a bit of an advantage in the Netherlands. Well, we were confronted with this issue a couple of years ago with the introduction of the EU regulation, as we already had the counterpart of DLR, NLR in the Netherlands, who had the privilege under the national regulation at that time to conduct testing with unmanned aircraft and also conduct those tests on behalf of other parties, third parties. So when we needed to convert that national certificate, actually, we were already thinking, well, how can we accommodate that within the European regulation? Yeah, and the first thing was, we looked at, of course, is, Article 12, when the mitigating measures are adequate and sufficiently robust. They had a system which was built on years of experience with working with test plans and a gradual approach, and identifying which technologies are experimental, which are proven, etc. So the advantage to me was, have a look how they did it so far, and then convert that into mitigating measures that are acceptable. At the moment, we see, the NLR has, well, their own little bit of airspace, because that is one thing with testing, experimenting, is that at the moment we only allow that in segregated airspace. So there's not enough of that. I think every country has a struggle with that. And also we do not like to, when we have segregated airspace or a dedicated restricted airspace, we don't want to have one owner or one exclusive user for that particular piece of airspace. NLR and DLR, again, being the exception. But we don't want to increase that. So we're looking at, together with our policy makers, with the ministry, looking at a dedicated preferential piece of airspace, quite a bit large corridor actually, to allow those tests to take place, and to make it easy accessible to new people that are not that, and operators that are not that familiar with aviation, to enable them to look for another operator like NLR, who has the privilege to conduct those tests at that specific site, but not necessarily applying for an authorization themselves. So yeah, I think that is the way forward. That's then a preferential area, and if that preferential area does not fill the needs to conduct the experiments properly, like this is over the North Sea, so if you cannot fly over North Sea for whatever reason, you don't want to fly there, or you need to be at a specific location, you can apply for another bit of airspace to be restricted, but we are very conservative in that, and it's both the policy department and us, the Civil Aviation Authority or the inspectorates, and together that we make a decision on that, who is eligible for such a bit of airspace.
Yeah, I think also to comment on the exact flagship action, what's already happening in flagship action 14. I can add that concerning this network, as you already mentioned, we have been blessed, I would say, to be one of the first entities to actually start coordinating test centers. So on one of the use-based stakeholder events from Eurocontrol last year, it was just basically the right people at the right place at the right time, because there was a dedicated workshop to this flagship action. And everybody agreed that we need to I would say, consolidate what the test centers are doing, because they are coordinated nationally, but not European-wide, and this gives us a little bit of a disadvantage. And once we saw that, we said, okay, let's just do it. We won't wait for anyone, which is why I don't know if Munish is in the room, but neither he nor I are getting tired of saying we, as the UAS Test Center Alliance, we are not the exclusive network of the European Union, right? We are just one of many, but I think we are one of the forerunners. We currently have 39 members from 16 different member states, so we are quite large concerning how many test centers there are. And we've been blessed enough to have, for example, the civil military exchange right from the beginning, because EDA was present at the event where we said, let's start this network. So we have this exchange going on, and it's a gradual approach, I have to say. So especially the military side, when they have to do something for themselves, they can be very quick, as long as there's a military application. When they want to do something together with the civil side, they take long. And so currently we are just trying to figure out how to collaborate with them. We've been invited to some of the DTEP meetings, but we can say that this flagship action is actually happening, but we'll hopefully elaborate on that. I think to the rest we'll come a little bit later in terms of test centers, what are we doing and everything. Yeah.
Thank you, Daniel. So now we have this group of people that met at the right place at the right time. It's established. So what are the advantages of having this group, and which kind of solutions are you proposing to allow testing?
Yeah. So basically our main motivation was that from running a test center, but also from discussing with other people, we always find the same thing. For the people from the industry, you have a new prototype or an operator who wants to test whether its operation is actually working as they plan. Most of the effort is not going into the actual testing, it's going into the preparation and finding the right place to test. So that was basically one of the first things that we said, we need to facilitate this. We need to be able to be found. And therefore, if we have a common platform where we, for example, create this kind of capability map, which is what we call it, we can give the operators and the manufacturers a common platform where they just type in, I want to do this kind of flight testing, and it shows you all the places in Europe where you can go, with all the pros and cons for each test site, of course, right? The other thing that we found was that, same as we had the discussions on the, I would say, associate level yesterday, it's very hard for the customers of each respective test site to talk to the authorities and have their voice heard. And so we said, to basically accompany what the industry is doing, we should do the same as test centers. So we should also not only work for ourselves in terms of the business case that the test center itself has, but look at the regulation, for example, and see how we as a test site can leverage this regulation for the people who are actually in need of testing, and therefore still take a bit of the load of the industry and the operators. And that was our main motivation why we said, let's just start. And what we started at the beginning of this year, after sorting ourselves out a little bit, was the preparation of a white paper, which we are currently finalizing, that is examining how can we leverage the current regulation and what different options are there, so that we can have short-term availabilities for more complex testing also in higher risk categories. And the things that we've been looking at was, on the one hand, the existing regulation 947 in terms of the look and also geozones. And also what we are looking into is, I would say, technical mitigations. We had some Slido questions yesterday and also some of the panel discussions where people said, I want to test in cell 3 or cell 4, but I can't because I have this hen and egg problem that I need to be able to fly in cell 2 for at least a certain amount of time to collect the data for my DVR. So this is something that is not in the regulation, but we think with a test center is probably easily feasible if we find a way that we can deviate from the OSOs, at least for a certain amount of time, to give you guys the opportunity to gather this data. And so these are the opportunities we are evaluating or have evaluated, and found that there's a lot of quick wins really to be achieved if we have the right interpretation, I would say. And we've also been discussing, therefore, with Alberto and Natale, very heavily on the look side. So it's possible to have a look as a test center, although I'm not an operator. And then I can, for example, take all the customers under my own umbrella. And they don't have to go through a SORA with the NAA, but they just have to, they just have to basically adhere to the processes developed by the test site. This is one thing we're looking at. And so I think as test centers, we can be a very good asset to the needs of the industry, I would say, not only in providing the infrastructure and the flight test range. And yeah, happy to discuss this further in this panel.
Please, Martin, if you want to complement.
Yeah, we also in the title here, it's also a network of test centers. What we are trying to do in the Netherlands is not only look at the location, because that's one important part, but it's not that essential in the sense that at the moment we have several operators with the privilege to, or the authorization to conduct tests at certain sites, not only at some fixed sites. So there are military CTRs, they're very popular, of course, military airspace, danger areas, restricted areas, they're all, and that's what we find if we talk about the cooperation of the Ministry of Defense. They're very willing to help us out here. So there are some operators with that privilege or with that authorization also the same as what we intend to achieve here, that they are able to allow a third party to operate under their responsibility, so to say. So I see, maybe we could rephrase that, network of test centers to, I don't know what, but operators maybe.
Thank you, Daniel. Thank you, Martin. So we see that there are two fronts then where we are approaching it. One is the technical, so how can we adapt and have means of compliance that are suitable for the peculiarities of testing. For example, testing is an activity which is very limited in time, which may be different from the, let's call it, normal operation that they may take place through an indefinite period of time. And then we have the operational side. So one of the options that was identified is to grant an LUC to the test center so that they can have the privilege to authorize this testing operation. This slide is just sort of a reminder of what an LUC is, what is required to obtain an LUC, and the fact that an LUC may come with certain privileges. So technical and operational side. And then the next question would be to Rocco. So we heard the perspective of an authority, of the test centers, and now from a manufacturer. So which are the challenges that you are facing with testing, and what would the, let's say, ideal test center look like for you?
Thank you, Alberto. I heard a powerful statement from Daniel that I love and I'm going to reuse. The operators spend more time in getting the authorization than actually doing the flight demonstration for compliance. I mean, this is a great statement, and it actually reflects our challenge. Our main challenge is actually the lack of opportunities to flight testing large UAS. In the last days, I've heard a fascinating word that is implementation, and I believe flight testing goes in parallel with implementation. It's a powerful tool for both the industry and the agency to show compliance, not only to specific requirements, but also to validate technologies that eventually we are going to certify, right? Many challenges were raised yesterday by PPCR Director Gabriel during the presentation, and I'm going to summarize a couple of them on how this affects the testing of large UAS. So due to the characteristics and the performance of large UAS, it's quite complex to operate an entire mission in a Sail 2 environment. This because most of the time this requires flying in a controlled ground area, 100% for large UAS, but this usually is also an airport, and airports have limited dimension to support an entire mission of a large UAS. So naturally, this flight testing ends in operations that are Sail 3 or Sail 4. And as Alberto mentioned, Sail 3 has already more stringent requirements that require flight testing to show compliance, but we cannot fly because we cannot fly in Sail 2. So how do we show compliance? And this contrasts a bit what was seen in the last decades for the manned aviation certification, where the compliance itself, the flight testing, is critical component of the compliance demonstration. So it's important that this missing element now for UAS is there, and we find a way to do so. Why this? This because it's important for both the agency and the industry to validate these technologies. As Gabriel said yesterday, we don't want to certify something that we don't know if it's the right design or not. So finding a solution is definitely very important to proceed with the flight testing of the large UAS. Another important challenge that we're facing, and then I will step on my ideal test center. I've been thinking a lot about it, but another challenge is that in the operation authorization, we face something that probably not everybody did, and is how the 2019-947 puts aside the recognized flight test organization. We speak a lot about new US operator, we speak a lot about LUC, but why not leveraging and exploiting the recognized flight test organization that have already a modus operandi and procedures that have been solid and robust for the last 10, 20 years and been tested with manned aviation? Why cannot we exploit this? So the question is actually safer to start with new procedures instead of relying on a recognized flight test organization? And going to the second part instead of the question, my ideal test center. In a sentence, I will say large, close, available, and that gives the, and cheap. Yeah. I didn't think about that. And that gives the operator also full control in terms of the operation itself. And I will explain why. So large, it's because to support large UAS flight testing, this test center can not only be airfields, football field, or airport in general. So we may think a bit out of this location. Close, because otherwise it becomes logistically complex, and providing daily support to operation is critical, in particular for long flight test campaign. And then available. The flight test campaign of large UAS does not really tolerate interruption. So we must guarantee continuity. And this is why I'm saying this. I do not know how many test centers are going to be available in Europe. But if we have 10 or 20 of them with 1.6 UAS operators, it becomes tricky to have a slot. So the more, the better. And another important point, apart from cheap, that I answered from Martin, is are the test center gonna challenge the regulation when it comes to the shortcomings of the regulation itself? Otherwise, we find again in the chicken and egg situation.
Thank you. So I noted your 4 requirements for a test center, and I actually think that this capability map can help to address at least a couple of them, like the size. So you can see which is the size, the availability. Probably this will not solve if it's close nearby logistically, but I think these are good inputs also as a sort of I don't know criteria needed in this capability map. And then I will go back to Martin, because we spoke about the LUC, and I would like from your, let's say, authority perspective, how do you see the evolution, let's call it like this, of the LUC as a certificate that is granted also to test centers?
Well, I think the LUC is an excellent certificate to be, like, you know, the privilege, you don't know upfront exactly what the ConOps is going to be. So you need to have some sort of room to maneuver, and the LOC is just a vehicle to provide that room to maneuver. So yeah, I think that's although the current operators that have this test and experimental privilege at the moment do not hold a LUC. I think it's a way forward from an operational control perspective, but also from a safety management perspective. So that's a good thing. Yeah, and like your problem with CO3 and 4, I'd like to remind us that SORA is not one fixed methodology. There's some room to maneuver. And if you, because of the CO3 requirements, related technical requirements, you need to prove that you actually, you know, meet those requirements by flying, and to avoid that catch-22. Yeah, I think there are many ways to mitigate risk when you do not, when you have not shown yet that you comply with some technical requirements. A very easy one is fly over the desert where nobody is in the next, well, 1,200 miles or so, and problem solved. There are no people at risk and no aircraft at risk, as long as you stay low, of course. But that's something that we can solve within that LUC regime, you know. So yeah, and then SORA by itself also, as it's not addressing the testing as such, you know, we always ask for whether it's under a LUC or an operational authorization, a separate risk assessment on how to conduct these experiments in a safe manner, in a controlled manner, and you can. Yeah. Long story short, I am in favor of a LUC as a vehicle to start with.
Thank you, Martin. Then let's speak about we spoke about the regulatory side, but let's speak also about the business case for testing. So what is the business case for the 3 actors represented here? And which advantages can have having this network test center and the LUC granted to test center. So who want to start? Maybe Daniel, please.
Okay, yeah, let me give it a try. So I think, Rocco, you already hit the nail on the head, because the business case of the test center, yes, we do have a self-interest, but it must not be harmful to the business case of the operator, because they are the ones who are in the end, or in the manufacturers, of course, but because you guys are the ones that in the end make the money and enable everything that we are striving for in the ecosystem, right? So we should always see ourselves in an enabling role, but within the alliance that we founded, we have this, I would say, approach to ourselves where we say we need to be available and affordable. And availability, you're absolutely right, is not only I am here and you can come, and because I'm located at an airport, if there's a commercial flight, you are grounded for the day. It needs to be the other way around, right? This, on the other hand, it reflects negatively in the business case of the test center. So I can give the example for the test center that I'm running in Kochstedt. The reason why we set it up as we set it up is exactly what you said, Rocco. We bought an airport. DLR is operating the airport as a research entity under normal rules. So we're an official international airport with all the privileges, but also with all the requirements. We do have opening hours and so on and so forth. But what we negotiated with the local aviation authority is that if there is a high-level campaign going on, we are able to close down the airport operation. We will have no commercial flights whatsoever. But we can keep the airspace running, we can keep the tower manned, and so on and so forth. So we have a closed airport for testing. This comes at a cost, however. So lucky for us, we were able to convince our government that we cannot have a full cost concept, as we call it. So if you would book a testing day in Kochstedt and we would give all the costs that we have and just refer it back to the customers, it would cost, I don't know, 25,000, 30,000 euros a day. For startups and SMEs, don't worry about it, don't even come, right? And so there needs to, this would be so harmful to the business case that we, from our funding perspective, can lower the cost, right? So we are at about 1 to 10 in the factor of running the airport, which is still expensive, but compared to what you get, it's not that costly in a normal thing. The thing is, also, when we're talking about improving or leveraging the regulation, you can have impact on what you're doing. So, for example, if you operate a look as a large test center, you won't have a problem. You will have the personnel. But there are, within our network, test centers that are run by 3 volunteers. If you have a look at the AMCs, you have to have at least 4 people, maybe not full-time, but 4 different people, so you can ensure compliance within your look, however you distribute your responsibilities, and then it might increase the cost for a lot of test sites. So it's always a trade-off. And for me, the paradigm only needs to be that we need to be able to keep the cost as low as possible. And then we will probably have some test centers which will be a little bit more costly because they can offer more, and you will have more direct access to infrastructure, to a look, to some other geozone, for example. And that's always a bit of a trade-off where we'll have to see where we go, I think. But this is something the ecosystem has to grow together. So we have to grow with the industry, with our customers, and see where we come out.
Yeah, and let me put a different perspective on business case. The Dutch Ministry of Defense just announced a couple of weeks ago that they allocated 400 million euros on testing and development of drone technology. And that money has to go somewhere, of course. Half of that is more or less allocated as aid to Ukraine. So I think, you know, from a military perspective, because we also address the civilian military cooperation in development of this technology, that's almost a no-brainer. And on the other hand, you know, of course, the technical perspective by itself, that's quite obvious. But also the development of further regulation. We know that VFR and IFR, so the instrument and visual flight rules, are not suitable for integrated use of airspace by unmanned and manned aircraft. We need to come up with, you know, like how to meet the essential requirement of the basic regulation, paragraph 243, that you, during all phases of flight, need to assure that you have appropriate separation with other aircraft. What is appropriate? You know, to answer those questions, you need to conduct some tests. You know, not only not only develop the technology, but how to use the technology in a safe way. So I think that's a little bit of other, you know, use case. You know, what is you know, why do we need this to be done? Thank you.
And before giving the floor to Rocco, maybe if I can complement from an authority's point of view, I see that I understood that it's very difficult to be fast in starting the testing. So having an LUC given to the test center may help in this case, because then the operators may go directly to the test center, and this may relieve somehow the authority from certain application for operational authorization. And then maybe some procedures can be tested by can be reviewed by the test center, but we will see later how the responsibilities can be shared.
Yeah, and also airspace. I mean, that's.
Yes.
I don't have much more to say. I think you guys covered pretty well. From the industry perspective, I mean, what Daniel says is actually on point. The test center, or anyway, any solution facilitating the flight testing, it's an important stepping stone towards our commercialization, and this is our enabler for us to go to the market. So it's indeed an important topic. It's interesting also to understand, probably this is a question also for the agency, if also you can have your own test center to test your technologies. But I did share the point of not wasting time to find the location where you can fly test. You can use that time to test. So getting closer to be ready for the market. When it comes to privileges, when it comes to benefits to also to the authorities, I guess the concept of the test center will offload the national aviation authorities from also the authorization itself, because we'll mainly focus on the LUC and the LUC for the test center. But at the same time, as Martin said, we are not only focusing on the development of the UAS. So during the flight testing, you're also focused on the validation of the technologies, of the procedures, and something very interesting that is the integration to the national airspace. So a test center, anyway, a solution for flight testing can only bring benefits to all the stakeholders.
Thank you, Rocco. And maybe just to complement having a manufacturer, having an LUC and being himself the test center. So there is nothing in the regulation that would prevent this, but obtaining an LUC is a big effort because it requires what is listed in this slide. So one option could be to have its own your own LUC and being yourself at the center. Another option is to share this burden with the center. So they will have to take the effort to comply with the applicable requirements, but then you can go without this directly to the test center. And the next question is about responsibilities. So anyway, when we will have a test, we will have a drone operation going on. There are responsibilities for the operators, for the remote pilot set up in the regulation, and someone will have to carry these responsibilities. So maybe for Daniel, have you thought about this in your discussion? How do you see this point?
Yeah, I think responsibility, we should interpret it in both senses, right? So on the one hand, no matter what we do and what privileges we give to a test center, also we as test centers have to handle them responsibly. Otherwise, we will incur risk, which is death to the industry, right? If we are too like, come do everything you want and you don't need to show us a safety case, that probably wouldn't be good. It would be good in the short run until something happens, and then it would be very bad. In terms of responsibilities sharing, I'm very pro flexibility in terms of, for example, if we're talking about the look, there's basically two ways, right? You can have a very, very stringent look where basically all people who come and run a test campaign are used as viewed as subcontractors under the current regulation. Then you also have to comply to, for example, a ConOps that the test center will develop. This might not be so beneficial to new prototypes, to very, very specialized UAVs like high altitude platforms, for example. As a test center, you will not be able to cover everything. So there needs to be shared responsibility, I would say. And so for something that's more off the shelf in terms of testing, I would say as test centers, we do not have any trouble taking full responsibility in terms of who is actually the one who's taking over the responsibility on the one hand, for example, under a look umbrella, could be something different as well, maybe, to do the auditing of the flight test. And therefore, you said it as well, Rocco, relieve the NAAs also a little bit of this burden. And on the other hand, I think the responsibility where nobody understands the technology yet should be shared a little bit by everyone, but in a, I would say, proactive manner where people are willing to take risks and not willing to avoid taking risks. And therefore, handing certain privileges to test sites would probably be beneficial, because then we can be directly involved in the safety case and not just supply the customers with, I would say, pre-formulated SORA texts that they can then use and to describe the testing environment, for example. I want to touch on one thing that you said, Rocco, also in terms of responsibilities of the test sites. I'm completely with you. Also as test sites, not as a threat to you, Alberto, but we need to stress and challenge the current regulation for testing. And of course, we need to do this together. And I think this white paper is one of the ways we are trying to do exactly this. So what we are assessing is basically a 2 to 3 step approach. So what's short-term implementation ready under the current regulation? Step 1. But then also what needs to be changed in the AMCs, in the regulation and so on. So it gets even easier. But this is something that cannot be done tomorrow, but it can be done starting in 2027, maybe, right? As we saw the timelines yesterday. And so those are the challenging roles that we as the test center network, I would say, take on as our responsibility as well.
Yeah, for our perspective, CEA, the ultimate responsibility lies with the operator. So that's the lock holder. And if the lock holder needs to use a facility like a test center or an airport, the airport has and the test center has responsibilities, but the ultimate responsibility for conducting the test as an air operation lies with the lock holder. And how that works with the third party being able to fly under the responsibility, then the third party becomes, after training, after assessment of the technical capabilities of the aircraft being tested, then the third party becomes part of that lock holder. Many times, the pilots that what we heard from NLR, when manufacturers come with the aircraft to be tested, then the pilots of that manufacturer know the system the best. So they have a system where officially the flight is being conducted by the lock holder, or in this case, the operational authorization holder, while the controls are actually the controls are in the hands of the manufacturer. So yeah, to again say, in the end, the lock holder is responsible for the operation, the safe conduct of the operation.
Yeah, so I said there are these responsibilities, and one possibility is to share them is through the contracting. So the LUC holder will have there are some responsibilities assigned by the authority, but then through contracting, subcontracting, there may be the possibility to share some of this responsibility with who is testing. For example, the test center may be very knowledgeable of a certain area, so the test center may take care of the contingency procedures, of the emergency procedures, and those procedures will have to be included in the testing manual of the manufacturer or the operator coming for the test, while the manufacturer can or the operator can use their normal procedures or the procedures to be tested together with these contingency and emergency procedures developed by the test center. This is one of the options maybe that can be considered. Okay. So if there is no other comment from the panel, I think it's time to open for questions. Maybe first we can see if someone from the audience here wants to make a question. I see that there are a few hands raised. So, okay, I saw you were the first. So, microphone is coming.
This is Nal. Thank you for this interesting discussion. Definitely the test centers could be an interesting solution, but also as you mentioned, the availability for manufacturers is very critical, especially that they go with continuity and that product development, even for new products. So there are a lot of phases that needs testing. So far, there are a lot of manufacturers, operators, and few test centers. This could cause some issues. Also, so other point which pop up in mind. So if the test centers can have some privilege why they don't be given to the manufacturers also directly, because they also know their products well. So this is another topic that just to be discussed. Also, there is now also 4 that could be exempted for flight tests. It's the only one which mentioned in the easy access rules that based on experimental flights, some NAA might accept not complying with the standards. So maybe this could also be used as part to facilitate some testing.
Yeah, so maybe I give an initial reply, then if you want to complement. So the privileges with the LUC come not only with the knowledge of the product, but also because there is let's say actually the privileges are the LUC is an organizational certificate, so it's not related with the design. And the privileges are given when the organization is mature, and when there are some, let's say, organizational parts in place, like the independent compliance monitor, an SMS in place. However, through contracting, the responsibility of taking care of the certain procedures that are needed for the test can be given to who is applying to the test center, while some other tasks are left to the test center. I don't know if you want to complement.
I think the reason why having a test center is kind of an intermediary, and why it could be helpful instead of giving the same privileges to an operator who will then use these privileges at some kind of testing environment, is some kind of economics of scale in terms of if every operator would be given the privileges, you could also operate under SORA. Although you have more privileges than SORA, but the workload for the authorities is the same, right? So you will have no acceleration. Whereas, as you said, we have a smaller amount of test sites than we have manufacturers and operators. So it's easier to basically supply the test sites with the certain privileges, at least concerning testing, right? It's not for the commercial operations in the end, it's only for the testing. And especially for the very early stages where it's most critical to be fast and to have a lot of iterations. Because then we only have to give privileges to, I don't know, 20, 40, 50 entities during the next short-term period instead of 4,000 members of JADA, for example. And I think this is something where time-wise we can expect a big leveraging factor in terms of then the test centers take on the workload that usually the authorities would have to take and supply you guys with your permits to fly.
Lino?
May I just add, one also important point is that why the test center may help here? Because the test center may focus on those mitigation that are needed in order to have the operation safe. For example, one of the mitigation will be the containment. So the test center, the authority will verify that the test center has very strong procedures in order to make sure that whoever is going there is using only the privilege that are more focusing on making the operation safe. So in this way, we can simplify also the life of the full operator, because if we may have an operator that is having a look. So the look will cover the full operation. So then we need to make sure that the full operation is safe. Instead, when we go there, the test center may be organized in a way that they can accept that, for example, you are in control ground area. If there is a crash in the control ground area, it's more a business problem, it's not a safety problem. So in this way, really, this can make a difference, because then we can focus on what is the safety relevant part of the operation.
Julie next, and then maybe we take the first start with the Slido.
Thanks, Alberto. I did actually put it on the Slido as well, so it's there. But just to go back to and I see at the top question there as well, is why we're not using the geozone in Article 15 and the exemptions from the open category to allow for an operator or an OEM to carry out their testing. The look option, I agree, it's a good option, but there's kind of really 4 really significant constraints. The first one would be the time to issue an LUC. I mean, we've seen with, you know, the amount that we've gone through, it takes a long time to get an LUC. The maturity of the safety management system has to be demonstrated. So how do you get a new test center up and running without a mature safety management system? Complexity of applications, the cost of attaining and maintaining an LUC as well. And then the other last one is the sharing of IP, where you may have an OEM coming into a test center. They don't necessarily want to share their IP with that test center who's also getting access to all these other OEMs, and then they can go off into the wilderness and set up their own OEM and have all of this industry knowledge themselves. So the open category option with the Article 15 geozone and removing the height and weight limitation seems like a really good option. Why introduce this complexity, or maybe do it as a two-stage process where we start off, use the exemptions in the open category, get the test centres up and running, get our R&D departments going, and then look towards the look maybe as a follow-up as these safety management systems progress and mature.
Yeah, I think, Julie, speaking from the test center perspective, I couldn't agree more. So in this white paper, especially for the short term, we had a look at what's already been implemented, and we can see that through the national aviation authorities, we have a geozone for testing implemented in Germany. It was temporary this year, but we're hoping to make it permanent. We have one in Denmark, we have several in Finland, in Poland, there's a big discussion going on, and so on. And we see that there's a big potential, as on the one hand on the short term, but on the other hand also because it's so easy to realize, right? So in the proposal that we write in the white paper, we say utilize geozones as much as possible, and in parallel start building this luck opportunity, because if you have higher than sail 2 operations, the geozone might be a little more complicated and it's not already well formulated, but I fully agree. And we need to leverage everything we can, right? And the other thing that I would also say is not only use this part, but also have a look at how can we allow for high-risk testing outside of the regulation, at least for an appropriate amount of time for people to get the data that they need, and pretend it's sail 2, although we all know it's not.
And I do also see there could be another disadvantage with the open category, and that is where the NAAs are going to have to carry out the air and ground risk assessment, really. So you're back to resources within NAAs. So while I totally agree and support the open category, there is limitations to that option as well.
But I fully agree, and I think as test centers, we are ready to go and to utilize whatever vehicles we have. So we should basically try to do it in parallel. And do it as quickly as possible, whatever is possible, right? Yeah.
May I add to that we already have some operational authorizations issued, well, with the privilege of testing and experimenting. So it doesn't have to be a luck, but I think it's a way forward for the long term. And also about the geozones and testing and experimenting, the problem that we face is that geozones can be instituted and targeted primarily at the use of unmanned aircraft, and don't affect that much the use of, or that much, not at all, the use of manned aircraft. So we took a different approach and just used the classical way to segregate airspace. And it doesn't have to be, you have several types of segregated airspace that the operation is completely segregated from other operations, or that we draft some conditions to conduct your flight, even when it's manned aviation, in a segregated airspace for conducting this integration testing. So that's what we're looking now in the Netherlands for. But you know, there's several ways to reach your target. So, but this is what we think now is the easiest way forward, the fastest.
Just to complement on the geozone, because we heard many times also the need to mitigate the air risk. Yeah, it's true that geozone can be, let's say, a risk assessment can be conducted and to allow more than what the open category is allowing. But we need to remember that geozones are visible only to drones. So there will, if we want, for example, to reserve the airspace, also something more would be needed.
Yeah, and one last thing, I mentioned it before as well, that use of military airspace. That's what we find, you know, especially in Holland, they're very welcoming and accommodating with, you know, within hindsight, the things that are happening in the world.
Then maybe we go, you wanted to take the next couple of questions? So, yeah.
Yeah.
Thanks. Stephane Ronek, Head of Section for Certification of Unmanned Aircraft System. And thank you very much for the first question. It's about the option to make use of Article 40 of the regulation to go into what we call certified category, or the approach we have when we certify or issue a type certificate for an aircraft. And of course, when you are in an area where the final product will be Cell 5, Cell 6 or beyond, there's a need to have a type certificate. And when you cannot start up, if in accordance with 945, 947, you would need a type certificate to start operation. So we are back to the chicken and egg, and we have an issue there. But it's not really an issue because we are in Part 21. We are in the scope of the regulations we have for certification of aircraft, and unmanned aircraft systems are aircraft. So we can issue flight conditions. We can have a permit to fly detailing the conditions and procedures for operation of an aircraft. The holder of the flight conditions, ideally, because we require a design organization for a TC, for Cell 5, Cell 6, has a DOA. A DOA is expected to have a flight test operation manual, so he needs to have the competence to perform flight tests. So we have a lot of pieces available to perform flight testing of higher risk of operation of unmanned aircraft system. Of course, we have not yet all the rules in place for certified category of operations, so there are some gaps, airspace integration, and we have a lot of experience in assessing the ground risk in accordance with SORA. So there is a benefit to then use elements of the SORA to assess the ground risk and the air risk, and to complement the procedures of the flight test organization with appropriate procedures, drone specific. So there is quite sure a lot to be discussed then between the manufacturer and EASA and the NA to set up the complete system, but the regulations are mostly available, or where not, we have the flexibility. And also in that context, a flight test center may play an important role. We have discussed here so far the 947, 945 as the framework, but also in a DOA may make use of an additional supplier of a flight test center, or outsource some of the assessments to a flight test center. So also in that scope, in that context, a flight test center may be very helpful.
Yeah, thank you. That's what, at the moment, you use a little bit of creativity and be a little bit flexible. That's exactly what we do. We look at 947 primarily, and then, we steal what we can from manned aviation, because that is, a proven methodology for years. So, and I believe here that to answer that Article 40, I think it's targeted specifically at manned aircraft development, but that doesn't matter. That the underlying, principles are very usable. So that's the way we, via the back door, we put it into, and in the end, it's Article 12, the mitigating measures are adequate, and we say yes.
Antonio, very last, then it's break time.
Thank you. Under Part 21, and therefore we can apply the principle of flight conditions. You may remember that we discussed some time ago the fact that it is not that this means necessarily that all is based on the flight condition issued by EASA. And this means, in another sense, that at the moment in which there will have to be a permit to fly issued by the National Aviation Authority to authorize the flight, a lot could be yes for EASA, but not necessarily all. And this reflects in a way the fact that the SORA has operational aspects, and some of them may not be necessarily addressed under the EASA flight condition, but would need the National Aviation Authority intervention.
Yeah, I can only support that. We have, maybe as explanation to everybody, the system is that the EASA normally approves flight conditions, which are focused on the airworthiness of the design of the aircraft, and the member state issues the permit to fly, amending it with operational conditions and limitations based on the operational rules and licensing rules we have in place. As some of these elements are not available for high risk of operation, at least not in that standardized way, there's the need to discuss what is placed where and how the responsibility is shared.
Thank you very much. Thank you for this interesting panel. Thank you for the question. And I think it's time to go for a coffee break now. So we join here in half an hour.
Yes, we reconvene here for the final session. Thank you, Alberto, and the panelists. There will be the two last sessions of the day, all together in this room, plus the final closing remark. See you in half an hour. The early implementation of these kind of operations, and what are the next challenges that we need to address in the near future to enable more and more automations, and we need to understand better how the tasks are changing, how responsibilities are changing, what are the challenges in the certification of the underlying technology. Please, Natalia, the floor is yours.
So welcome to the last part of our today's event. Your pain is almost finished, or maybe it's more my pain that is almost finished. So now we're going to discuss the impact of automation on drones. So we have here a representative of authority, Giovanni Barraco, Director of Regulatory and Research Innovation Mobility of Department in the Italian Civil Aviation Authority, ENAC. Stephane Ronick, Drone Certification Section Manager in EASA. And from industry, we have Diego Fernandez Varela, Regulatory Compliance Certification Manager in WING. So he's responsible for the activity in Europe. So what are we going to discuss? We are going to discuss the impact of the automation on drones. So how this may reduce the pilot authority, what will be the impact on manufacturer, the impact on the operator. Let's understand what we are talking about. When we talk about automation, we talk about such kind of drone that has been designed in a way that the pilot intervention can be reduced. For example, let's take into consideration two types of operation. A drone in a box, so a drone that is located in the middle of an area, so there is no human in the vicinity. So someone will press a button, the box will open. There is no pre-flight done by any human, so at least the pre-flight is fully automated. And then the operation is conducted. So, or another kind of level automation that we are considering is where we have an operation where there are multiple drones that are controlled by a single command and control unit, where then the pilot interaction is lower. So maybe also the pilot skill may be lowered. So we need to understand in which cases we may have a reduction in the human intervention, and then how this should be managed from the operator perspective, manufacturer perspective, and then the impact on the pilot. Maybe not only pilot, we may also consider other figure within the operator. So what we are going to consider is that when the level of automation increase, maybe the skill of the pilots may be reduced. So at this moment, here we are not discussing the operation fully autonomous. We don't know that at this moment. We know that we don't have an operation where there is no need for pilots at all. So there always need to someone that is monitoring the activity. So in the future, we will consider operation fully autonomous. Now we know that most operations are automatic. This means that the operation is pre-planned. There is a flight plan that is produced by the operator, uploaded on the drone, or maybe we can see that in other cases there are some setting that is put on the drone in order to make sure that the drone do conduct an automatic operation, but in a safe way. But I think that maybe we will see how, for example, Wing is conducting this kind of operation. So what is the impact on operator and designer, and what are the required skills to the EASA operator? So now that we understand the frame of the operation, let's start with Stephane. Maybe you can help us to identify what kind of type of automation we are discussing.
Yeah, we are discussing a lot of automation. If you look at this chart with a level of automation starting from direct control to full autonomous or highly automated operation, we rarely see a direct control, or we may even struggle to approve or authorize operation with an aircraft with direct control, because even there is a certain level of automation required. We have an envelope protection requirement starting from the SORA implemented in our special condition light UAS. We have requirements for contingencies partially performed automatic, for example, when you lose the C2 link. So we start already to mandate certain levels of automation on UAS to be able to be operated safely. And of course, this needs to be considered by the manufacturer designer, and he needs to have an appropriate system architecture, and he has to implement appropriate functions. For example, when looking at the airspeed control, probably most drones operated in low level beyond visual of sight will manage the airspeed or the trajectory or the speed or ground speed or whatever is the function that's driving will be done automatically. So the designer needs to consider this. He needs to decide if there is an assisted operation, for example, we have discussed manual operation, that he would directly control it, probably should not be there. He might have a role in the loop. He has an assisted operation. It could be a system like on a quadcopter stabilization system, where the pilot is flying, but there are systems on board of the aircraft which are needed to make him able to do this operation. Going upwards on the slide downwards, supervised automation, when we have the human more on the loop, and that's the example I was mentioning, airspeed management. There's probably more the pilot or the crew on the ground is monitoring what the drone is doing. And in certain cases, it might be needed that the pilot is stepping in, intervening into that management of that function. And of course, going to more automation, high automation, we have the human not anymore in the loop. We have a pilot, crew monitoring what is going on, but the aircraft is dealing with the problem, and ideally, and then it depends on what is expected from a pilot. In case something is not working as expected, the pilot must have the means to step in, to intervene, or probably the machine has the appropriate level of redundancy and development assurance and can deal with a problem, and the person on the ground, the crew, the pilot, is continuous monitoring. He might intervene, he might abort the mission, but he will not directly intervene into the management of that function.
Okay. Thank you. So I think that we can here take the first message is that when we talk about those drones that are today approved for the open category or standard scenario, they already include some level of automation, but this does not allow the operator to reduce the piloting, the human intervention. So I cannot take a drone in the open category, upload the flight path, most probably the drone will conduct the operation completely without any need for intervention, then maybe I can take a coffee. This is not possible because since the function is not designed properly, we don't know if then something will happen. So it always is required to have a pilot that is monitoring and take control when it's needed. So we are talking about up to level 2. So what we are going to discuss on this panel, so is more on level 3 and level 4, that really then will enable the reduction of the human intervention. So, question for Giovanni. Now that we see that so we know there are quite a number of operations, so can you help us in navigating between the responsibility of the manufacturer, operator, pilots, so how the automation will have an impact on those responsibilities?
Thank you for the question, Natalia. Good afternoon, everyone. Obviously, the correct definition of roles and responsibility is fundamental in the US operation. And we have to say that obviously taking into account the possible automation that is implemented in the US. And obviously the overall responsibility on the safety of the operation is in charge to the US operator. And the US operator needs to develop procedures on the basis of the also the manufacturer instructions that are defining what are the specific features of the US and needs to implement these procedures. All the personnel must be well trained and aware on how the operations must be conducted. Must to define the training for the remote pilots and generally to all the personnel involved, as said, on the basis also the instruction about the minimum level of the training that is described from the manufacturer for specific type of systems of or features of the US. And from the remote pilot side, the remote pilot is responsible to conduct the flight planning, to perform the flight operations in accordance to the procedures established from the operator. And from the manufacturer side, obviously, when we introduce higher level of automation, we need to rely on the system. So the manufacturer must design safety system that are safe, that ensuring that the features and all the specific particularity of the system works properly and safely. Obviously, the manufacturer should need also to, on the basis of experience gained, to share updates on their products, and on the other side, the operator must be up to date about this new information about safety that could arise from the service experience. This is in general how the responsibilities are divided.
Thank you, Giovanni. So in the meantime, there is a survey that has been launched on Slido. So if you want to answer, so we can see what is so far the level of experience that we have here in the audience. Now, Diego, Wing is conducting operation with high-level automation in Europe, in US. So how are you going to manage, how you conduct your operation?
Yeah, so automation plays a key role in nearly every component of the wing delivery system. And this allows for significant reduction of the human intervention in the majority of operational aspects. So I wanted to present a slide because it clearly outlines the different stages of a typical wing delivery mission and how automation is embedded within each of them. So everything starts with an order via an app. The goods are prepared and packed into what we call the Hextot, which is the custom design water-resistant box that you can see on the left. So as soon as a delivery request is received, the mission is automatically assigned to an available aircraft, and the wings planning system automatically computes a safe 4D flight route from the launch facility to the pickup and delivery locations. This 4D flight trajectory takes into account the aircraft performance, the surface, so the profile of the surface, and of course the operational volume boundaries. And it is deconflicted from airspace restrictions, operator restrictions, and other known aircraft, including our own aircraft. Regarding automated checks, so the aircraft, before a delivery mission, runs a set of automated checks aimed or designed to verify the health of the systems and the warm batteries. If any issues are detected with these checks, the aircraft will automatically reject the mission, will not take off, and the mission will get reassigned to another available aircraft. So the aircraft will take off automatically and fly to the pickup location, where it will hover at around 7 meters above the ground. It will then lower the tether, and the package will get attached to a specialized hook. Then the aircraft retracts the tether and secures the package with locking pins for flight. Upon securing the package, the aircraft automatically transitions, well, first of all, climbs to the altitude, to the cruise altitude, which, as you can see there, is around 30 to 40 meters above obstacles, and then transitions into forward flight at an average speed of 100 kilometers per hour. Then, upon reaching the delivery location, the aircraft will automatically lower the package and release it upon making ground contact. So once the delivery is completed, the aircraft will automatically return to the launch facility and land on a charging pad where it will recharge batteries while other aircraft serve other deliveries. So all this is possible because the aircraft, which is specifically designed for airborne deliveries of small packages to people on the ground, is constantly performing health checks on its systems before, during, and after a delivery mission. So with high automation and multiple levels of redundancy, the aircraft handles all tasks associated with the mission in a predictable manner and independent of connectivity, including of nominal conditions, thanks to the onboard contingency management system. Part of this onboard contingency management system is the capability, which is also available to the pilot in command, of performing a contingency landing, which is essentially a low speed control hover descent, which happens or which takes place in a preferred landing area where it is less likely to encounter people or traffic.
Yeah, so I see that the interaction with the pilot is very minimal. So everything is based on the way the drone is designed. So having this function able to to meet the target level of safety that is required for this kind of operation. So a question for Stephane. So what could be the process for a manufacturer to design a drone that has some automation that may reduce the human intervention?
Of course, the manufacturer needs to have a quite detailed concept, in that case, quite a detailed concept of operation in mind, and needs to make certain assumptions on the possible intervention of any human involved or being involved in the operation, and how it could be. For example, we see here order and preparation planning assignment. This drone will be at the end qualified to certain environmental conditions, and it needs to be ensured that the aircraft or the operation is within the limitations and conditions for that aircraft. So the manufacturer has to do some assumptions, either provide systems that are supporting or taking the decision to take off or not take off, or when there is a need to have a human taking a decision or possibly intervene in that operation when the environmental conditions are not anymore as required for the operation, then it needs to ensure that this person has the appropriate information and knowledge. And information is quite important. Of course, we will have a lot of systems on those aircraft. And those systems need to be designed meeting the safety standards that's required for that operation. But the systems will somehow interact or will provide or will have to provide information to the operator. It might be quite limited when you have a fleet of these drones and you have a limit or only one to many. You have one crew member, one pilot monitoring and controlling multiple of these aircraft. You cannot have 20 screens where you have all detailed status information of every system on the screens. The human will not be able to process that information and to manage that fleet of aircraft. So the manufacturer needs to identify what is the important information that needs to be available for the crew to allow him to manage that flight. He also needs to consider human factor, prevent human error, and probably install systems or develop the systems that they can mitigate or enable the crew to manage those errors. So, for example, when there is a case of an intervention in the flight, the crew should know to which of these drones he is talking, or which drone he is controlling, or he's taking action. He should not terminate a flight of a drone which has no problem because he sees a red alert on a display somewhere. So the system needs to be designed to enable these kind of operation, to support the crew, to take decisions, to intervene when needed. And of course, the manufacturer has to take some assumptions on the required competence of those humans and to pass this information to the operator.
So I think that's what we are saying, that the manufacturer is the source of the information. So he's the first actor that they need to identify how the drone will be operated. And then if they maybe also considering what Wing here is presenting, they are sort of segmenting the operation. So maybe the manufacturer may use a similar approach where we identify an operation will be segmented in pre-flight, in takeoff, in cruise, aerial work, and whatever, then depending on what is the operation, the purpose, then landing and post-flight. Then for each of these phases, they may identify if they are using the human as a mitigation. So it means that, for example, the pre-flight, if you go to drone in the box, the pre-flight will be done by a person, or instead, if they are developing some automation, like cameras or whatever, that is providing the same level of safety as it was the human, and then we can avoid to have the human. So this can only be done if then that function has been designed properly And then what then will be the operator responsibility? So Giovanni, what do you think? So once the manufacturer will have identified that they have designed properly some function, maybe then there will be written on the manufacturer instructions what is the minimum level of skill that is required for different functions. So how then the operator will be required to manage this information?
Thank you, Natalia. Yes, if the operator wants to use the automation features that are allowed from the manufacturer, obviously he has to develop procedures for all the phases of the flight. Pre-flight procedures covering the possible built-in tests that describing the tests that are self-done by the US and describing the level of human intervention in those tasks. The in-flight procedures to manage all the possible events that can happen during the operations, and emergency response also for the cases where something in exceptional cases something happen during the operations. The operator obviously has also to develop the training for the personnel involved in the operations. This training, as we said, based mainly at beginning from the manufacturer instruction, should cover the system understanding, especially in case of highly automated operations, the human interface system, which kind of information are put available to the pilot, to the remote pilot, and how we could manage this kind of information. And also the personnel must be updated on the possible new procedures that the manufacturer will issue. And obviously it's important to focus on the criticality of the planning phase. I mean that must be correctly set all the procedures that needs to be followed in case of emergency, abnormal and emergency situation. And the manufacturer obviously can provide all the information concerning the particularity of the system in case for specific scenarios to be used.
Yeah, thank you. So, as you said, the skill of that the personnel of the operator needs to have will be heavily impacted on level automation. So maybe it goes a little bit beyond the pilot. Then I don't know, Diego, if we can still call pilots, because I understand that you have some authorization outside of Europe where there is a person able to control multiple drones. So can you explain what is the maximum authorization that you get, and also how you are going to train this person?
Yeah, so well, as you may imagine, our system is designed such that a single pilot can oversee multiple aircraft in a given operating area from a remote location. So the duties of our pilots essentially involve those areas that have not yet been completely automated. So this includes, for instance, the monitoring of weather conditions, of surrounding crewed air traffic, the adherence to dynamic flight restrictions, or the communication with ATC or law enforcement authorities as needed. So the pilots cannot manually control the aircraft, but they have 2 commands available to intervene on an exception basis to address an off-nominal condition. So these 2 commands available are, on one hand, the pause of operations, so simply and I know Kevin was from MANA was mentioning this. Essentially, is to allow airborne aircraft to complete their mission while preventing new missions from taking off. And then land now, which is essentially a contingency landing that I was mentioning before. So the competency of our pilots is basically defined by their capability to effectively execute their operational duties. In addition to our pilots, we also have what we call ground support operators. So their competency is defined by their capability to swiftly respond to a variety of situations requiring hands-on human intervention. So this includes from troubleshooting certain electrical contact issues at the charging pads or the execution of the emergency response plan. So all this allows us, for instance, to have a 1 to 100 approval under Part 107 in the US, or here in Europe as well, 1 to multiple aircraft operations.
So you mean that this remote pilot control up to 100 drones that may be at the same time in the air. So most probably, if they need to communicate with the tower, so I think that then the skill of what is required of this pilot should be very limited, because then there is also a workload verification that you had in order to verify that at the end what this pilot needs to do is compatible with managing this 100 drone, and that maybe a number of them may be in the contingency situation or maybe in emergency situation. So I guess that's
so the commands available to the pilot can address 1 or more aircraft. So that allows to reduce significantly the workload.
So this means that maybe there will be both the theoretical and practical training required for this kind of person is not exactly the same of what we require today for a drone that is operating in the open category, or where they have they can take direct control of the drone and then steer the drone in a different direction. So you were mentioning, Giovanni, regarding the possibility to consider also other figures, like you were mentioning the planner, because maybe the planning phase is becomes very essential. So can we explain what may be this person that is conducting the planning of the operation? What are the challenges?
Yes, Natalia, the flight planner is a sort of figure that in a highly automated systems, in this case, would be without the highly automatic functions, would be the remote pilot. In this case, the term of the remote pilot is evolving, and is right to have a question if remote pilot is a term that can correctly describe this role. In any case, the regulatory framework is already has been designed, taking into account the introduction of also autonomous flight and in fact, the responsibility in this case is moved from the remote pilot to the US operator. And in this case, procedures, specific procedures on the automated function are necessary. And also the SORA framework cover the skills and knowledge that the personnel of the whole personnel of the operator US must have. Probably could be necessary a guideline to facilitate the transition of the towards highly automated operations, considering could be better define the training that is necessary, and also the other aspect that needs to be took into account, such as the definition of roles and responsibility between this new figure of pilot and the operator.
Yeah, thank you. So this means that so with automation, we may move from a remote pilot to a fleet monitor. So a person that is more in charge to identify that the conditions that makes the operation safe, so environmental, or if there is any other obstacle in the air, are within the limits of the operation. Then, in case, abort the operation and activate the emergency response plan. So this will what will be needed. So maybe then the theoretical and practical training may be quite reduced, may be much different from what we have for remote pilot. While instead, within the operator, we have this new figure that is the flight planner, that from a theoretical point of view, they need to have at least the same training of the remote pilot. Maybe even more, because maybe it's a little bit more challenging, because he needs to anticipate all possible contingency and emergency conditions that may happen. So already pre-plan the response to the drone, so that then this flight monitor should potentially never intervene, because everything is already predefined before the operation. And then instead, from a practical skill point of view, maybe this flight planner also here, they may have a limited skill. So maybe we should, when we discuss about what is the training for the operator in the specific category, we should so not only focus on the pilot, we should focus on the full training of the operator, because then there may be a different figure. And so allow some kind of flexibility, and then maybe is the operator that will identify, based on the input for the manufacturer, what is the training required for the different skill in order to fulfill with all the elements that are in the regulation. And as you said, the regulation already today is flexible because they give responsibility to the pilot, or if the drone instead have high-level automation, then this responsibility may be transferred to the operator. So I don't think that there is any need to change the regulation, maybe just to clarify better in the SORA. And so we have, that we have a safety, an operational safety objective dedicated to the training. So maybe to better clarify how this will be done. So maybe we can show the result of the survey. Let's see what was the answer, and then we can then check the questions. I see that there are some questions. Yeah. So there were 2 surveys. So if you're so the first survey, if you were operating a drone with level automation, was to understand. So we have 63% of the audience that are using already drones, where in some cases there is a reduction of human intervention. So this means that automation is something already happening today. So this means that also when we are going to consider the training in the specific category, we need to take into account that it's not the future, it's the present. Yeah, it's even getting higher. And then the next survey, so in what kind of automation? Landing full automated with no person monitoring it is the first one. Then also the takeoff. Maybe that's maybe the easiest. Yeah, but we still have cruise and aerial work with a remote pilot that control more than 1 drones. Also, it's quite high. Yeah, so these are all functions that we need to consider. And maybe what Stephane and I need to work is on some procedures, maybe standards. So how to allow manufacturers to design drones that's where they can claim that we don't need any more pilot in the as a person, for example, in the pre-flight, or they can monitor more than 1 drone, up to 100, as is in the US. That is a big number, actually, 100. Very big. Okay, so let's go to the question. We still have 15 minutes. Let's see if the questions that we have. Maybe we can go to the, if there is any question in the room. In the meantime, let's read the first one. So Regulation 947 allows autonomous operation. Yeah, exactly. But we lack AMC for ops where remote pilot is not monitoring in flight phase. Yeah, exactly. This is what we said before. So from a regulation point of view, it's fine. We need to work a little bit on AMC. So then the outcome of this panel, we will try to continue the discussion in the next months to develop some guidelines. Then we will publish on the EASA website to offer to authorities and to operators in order to start allowing this kind of operation. That it also will be a way for us to gain some additional experience. And then as soon as we have a mature procedure, then we will transform into AMC for the Regulation 947. So this will be both for the training and for also the development of the procedure for the operator, and also for the manufacturer, how to test, how to develop functions that are designed properly. Next, redefining the traditional role of a remote pilot for highly automated system will also lead to different qualification license scheme. Is EASA looking to work on flight monitor or equivalent licensing? If yes, when are those being published? So maybe, Giovanni, I think it's in the ARIS task force. So we have an ARIS task force within the TAB. The TAB is the advisory body made of authority, and the ENAC is leading this task force, not to Giovanni, but to a colleague of Giovanni. So maybe you can provide some information.
Yes, there is the task force that is working on new requirements for the specific category. And so these aspects are going to take into account in the work of the task force. And in the next 2 days, there will be the US technical body, and will be discussed also this aspect. So.
Thank you. Yes, exactly. So tomorrow and after tomorrow, for us, it's not finished. So we'll continue with all the authority to discuss similar topics on how to then improve the regulation and how to harmonize the implementation of the regulation. And this will be, it's already a topic that is in the agenda. And so we'll have it be discussed. Diego, I see a question for you. Still, you can answer the same question.
I will go for the pronounced question. Yes, so we have developed a highly functional simulation environment, and it has already been included in some of the approvals that we hold in some markets that we operate. And basically, this testing environment allows us to test our normal operations, but also against a range of conditions, inducing failure conditions, in the presence of other potential airspace users and how we react to them, and also, of course, stress high capacity testing. So essentially, yeah, this allows us to build confidence in our systems, and yeah, it has been already included in the approval.
Thank you. So an interesting question from Andrew. So in case of highly automated device is involved in accident, are there existing guidelines to determine liability? Unfortunately, we don't have any more Gerli, our legal expert. So I don't know if any of here in the panel have information on how to answer.
No, in my view, it's important to establish what could happen in that case, and on the basis of the procedures, the operator procedures, the liability can be decided. As we said, the pilot has the responsibility to follow the operator's procedures. If in the investigation is clear that the pilot has correctly followed the operator's procedure, then in my view, personal view, the liability is to the responsible, to the US operator.
Giuseppe, want to complement?
Yes, just to complement the answer. In the framework of the Rulemaking Task 230, there is a working group that has been established, which is focusing on the legal matters and legal aspects. Basically, we are trying to come up with the future evolutions of the Regulation 965/2012, trying to identify the responsibility and liability exactly in a framework of complex US operations. So we have started looking at some initial concepts coming from the ICAO framework, coming from the European regulatory framework. And we will continue working on this. So it's a kind of exploratory work, trying to define new concept and new approach. The working group is composed by aviation legal experts, pilots from the agency, and we are counting to expand to the let's say the membership of this working group in the future by taking on board industry's expertise in this domain, so that we can commonly discuss and agree on the future regulatory framework.
Thank you, Giuseppe. So a question regarding the Azure drones that we saw yesterday that is already providing this concept on the box. So I think nobody here from the panel were involved in the authorization. So I don't think that we can answer on this exactly topic. I don't know if anyone here in the room may provide some additional detail. But we saw from the survey before that 67, maybe 70% of you, or those that answered, are already using drone with some kind of level automation, reducing the human intervention. So Diego showed that Wing as well. We know that we saw that also Manna, other operations. So yeah, it's possible. At this moment, I think still there are some limitation in terms of the level of sail, the level of air risk, ground risk. So because then in order you need to design the drone with the function that is meeting the level of safety for the air operation. So then if you are operating in a sail, in high sail, so maybe because you are either in an area that is populated, so you can damage and kill people in case of crash, or there is an area where there are the air risk is high, so then maybe the level of this level of design will be a little bit higher. So I don't think that at this moment we are having operation in the higher sail environment. Is it correct? So maybe you can describe in what kind of operational environment you are doing this operation.
So, well, we operate BVLOS in populated environment, and so we essentially operate the same globally, and focusing on the SORA methodology. Our approvals in Europe, here in Europe and in Australia, are based on SORA. So yeah. Responding to that question, it is already possible to be approved based on SORA for highly automated operations.
And this is a SAIL 2, no? A SAIL 2
Yes.
operation. So this means it's in a lower risk environment. Yeah. And you also make use of the characteristic of your drone that is light. And so I think that when we go to an operation, a sim operation that is in SAIL 4, either because your drone is bigger or then maybe needs to be designed with different standards. So maybe I'm not sure that we can allow today. There is maybe one question that we could ask: how many operations in SAIL 3 or 4 are today with high level of automation? Or maybe this would be more interesting. But maybe in the next panel. There is another question for you on if you use airspace observers.
Yeah. So both in Europe and Australia, we don't use airspace observers. While in the US, it used to be somehow required, but our approved detect and avoid essentially mitigates that need. So it is a matter of requirements rather than real reliance or dependency on airspace observers for detect and avoid.
Thank you. So there is a question that uses the word type certification. Type certification means Stephane. So automatically is your question.
The question is whether the growing technical complexity from an aircraft will lead to the need to have a type certification. That's not the case. Definitely not necessarily. The need for type certification is depending on the risk of the operation. So for SAIL 5, SAIL 6 operation, you would need to have a TC, while we are seeing high levels of automation also in lower sail levels. We should also consider that, okay, it's adding technical complexity to make a drone highly automated, but not necessary in all areas. The human-machine interface might be much simpler than a drone being more or less manually controlled, and a fully automated drone might have some advantages compared to a system which is mixing or enabling different modes of operation, where a pilot may be able to control the drone, but still there's a need to have a flight envelope protection on the drone. So automation does not, at least not in all areas, need to technical complexity. And of course, then there are different means to show compliance, and there it would be needed to look into the, if you are in the lower sails, into the required OSOs. If it's highly automated, you may want to look into also 5 system safety. That's definitely recommended. And we have means of compliance, and they are different for medium risk of operation and for high risk of operation. So when we are going to high risk of operation, the required safety levels on those technical systems are quite high. And then we require a type certificate. And in that case, it's also required to have an approved design organization, which has the competence to address complex issues that will then show up like development assurance.
Thank you. Is there any question from the audience? Please just raise your hand, and then can give a mic to Costantino.
Yeah, thank you for this very nice presentation. As we're having many operators interested to apply several automation features today. I think that 6 level of automations presented, and also regarding taking according to the regulation that apply today, up to what level of automation is the competent authority allowed to provide an operational authorization, and also who is responsible to decide what is the level of automation?
Yeah, so I think that this panel we try to address the core of this question, try to identify that. So everything starts then for the manufacturer. So how an EA can authorize to reduce the pilot intervention. So maybe, for example, not have any pre-flight. So will be only based on the fact that first of all, the manufacturer showed that they have some technical feature that may guarantee that the minimum level of safety will meet. Now, depending where the operation will take place, because if I have a drone with a drone in the box that is starting from the middle of the city, then I need to have so this will be high sail operation. I need to have a very, very strong automation system properly designed such that is meeting the level of safety of that sail. If the drone in the box is in the middle of the countryside, then would means that it's a lower sail, so it will require then a different design. So I think that's what we should do is that all the time we should assess the level of risk and how the drone has been designed. Maybe what we are going to define in the future is some guidelines to try to provide some best practice, some also good example that we can find from different parts of Europe, such that then we can harmonize how all the authorities in Europe are using the approach. Then will be consistent.
Okay, thank you.
So we have maybe still time for last question. Many of these operations will be artificial intelligence based. And now we go to the difficult part. How risk assessment of this function can be carried out and how soil authorization can be obtained. Maybe you can.
That may be an interesting topic for a workshop in the next event. In general, okay, it's a very good question. Of course, it heavily depends on the role of those functions that make use of artificial intelligence. If this is if a malfunction of that system can lead to a loss of control, we would really need to look into this and discuss with the applicant or with the manufacturer how to qualify that system. We have guidance how to address AI published. EASA is quite advanced on the topic. We have not yet applied this to an unmanned aircraft system, so that's a subject for discussion. But of course, it really depends on the safety impact. So in many cases, AI is used more related to the operation of the payload to perform the mission, but there can still be a system, or there may be the need, or it may be recommended to have a system that's somehow containing the operation or ensuring the safety of the operation of the unmanned aircraft system. So that, for example, the detailed control or the flight path within a safe operational area may be impacted by an AI-based system. But on top, there's a deterministic monitoring system that ensures that those drone is staying in a safe area. Then our assessment and also what is needed to demonstrate could be quite relaxed.
Thank you. So I think that the takeaway of this panel is that automatic operation is a reality, but we know that the majority of drones on the market already have automatic operations, but they can reduce the manual, the human intervention only if the manufacturer have designed properly. So what we are going to develop in the next phases will be some guidance to help manufacturers to identify how they can design properly. We know that there are also some standards that are already undergoing in some standardization body that may help. And then this will have also a big impact on the training of the different personnel of the operator. So that also, this will be quite a change in our mindset compared to what we have in manned aviation. So thank you very much for the panelists, and a round of applause to the panelists. Thank you.
So we're slowly approaching the last session of the day. And the last one will be moderated by John Franklin. John is our head of safety promotion here at the agency. The session will focus on what does it need, what is needed to establish a right safety culture and a sharing of intelligence in the drone community. It being a new domain, it's not easy, well, it's not always common to find organizations that have this culture, which is more or less spread across the, let's say, legacy organizations, and there is a need to foster this attitude. So let's see what can we do together to achieve this.
Exactly. Good afternoon, everybody. I hope you've had a really good day. Lots of really technical discussions. So hopefully to finish off the day, we're going to shake things up just a little bit, perhaps ask some philosophical questions about what we collectively as the drones community can do when it comes to occurrence reporting, safety promotion, and really get us, I guess, thinking about what's the point of all of this? How can we collaborate and work together? And how can we really make a difference to this growing part of the industry? I know it's a bit late in the day, so I thought I'd start by sharing some of my holiday pictures with you. Oh, hopefully this works. Oh, there we go. I thought I'd tell you a little bit story. So we recently had, we had an event we went to, really interesting conference. Really nice place, met lots of lovely people. It was a really amazing opening ceremony at this conference. Fantastic. Now, you wouldn't come home from a really fab trip and show all your friends proudly a bunch of pictures that look like that. But when we don't use occurrence reporting to the full extent possible, that's effectively what we're doing, whether it's in our organizations or in the drones community or in any part of the aviation community. You know, if you're running an organization or a business, you're not going to make good business decisions based on that much information. The same when the colleagues here who've been running this event in the drones team are trying to make new rules and trying to decide the path that this part of the industry takes. If nobody's ever told us anything and we have decision-making pictures that look like that, the only thing we can do is potentially make rules stronger than they need to be. You know, people say, why does a regulator over-regulate, write too many rules? One of the most obvious reasons is because we don't have the picture to take away the uncertainty that we would like to make a better or a different decision. And that's really what's at the heart of this conversation. Oh, can we do the next slide? Is that? It's not. Generally, there are 3 reasons why we do safety reporting. I think probably most of the drone community, perhaps, you're in the left side there. If something happens, you look around and think, did anybody see that? Am I going to have to tell anybody what just happened? And that's kind of the first reason why most people report, even whether it's an airline or an airport, much as we might like to think everybody's altruistically thinking, let's report a safety event for the wider good of the world. The reality is we're very much in that left box. And without trust, we don't get out of the first box. The next reason we report is because we're worried what the regulator or the person that might be auditing us is going to say if we don't. We know you had that event and therefore type thing, and we're doing it because we're complying with a rule. And where we really want to get to, and where ultimately the goal of reporting hopefully takes us, is that we're in that mindset, that feeling that we want to report because together we can safely grow this really amazing, exciting new part of the aviation industry that you're all part of creating. And that's really what we're ultimately trying to do. So it's about learning, but it's not just about learning. There's lots of talk of the concept of just culture. And when we started talking about this presentation, we started saying, well, it's about just culture, isn't it? But that's just one of the cogs that drives the world of safety. The just culture is driven by the trust that creates the reporting culture, that creates the reason to report, to tell people things. But if we never do anything with that information, it just disappears into a black hole, then we lose that willingness to learn. And if we're not learning, the cycle's not continuing. We need to be flexible enough to know we need to learn. And then we need to use that, be informed. And this is then where it links to the safety promotion work that our team's leading, to take all of this information that you provide us and to use it to help share information with the whole community so everybody can learn from all of the things everybody tells us. So ultimately, that's what we're trying to do. Now, when we talk about just culture, it's particularly important to stop and think for a few minutes about who is just to who. And I think as a community, this is one of the challenging things. We've done a lot of work, particularly with the GA community, who are still kind of going on this journey a little bit. But when most people think about just culture, and certainly the way it's broadly written in Regulation 376, is it's about staff who work for an organization, and people think of a pilot reports something and how is their airline going to act, or a ground handler, or whatever it is. But one of the key relationships, and particularly in the drones community, where similar to the rotorcraft community, you have large numbers of very small organizations, as well as a few big and a few medium ones, etc. A lot of this is about the just culture relationship between the organization and the national authority. And one of the key things is if, as a new drone operator in a country where the market's just expanding, something bad happens, it hopefully doesn't involve injury or damage, but somebody reports something. Now, when that's the first or second and one of the first reports in a particular country, it's really difficult. Something bad might have happened here, and it's about applying that just culture in the same context and saying the only way an authority is going to get the trust of its drone community to continue reporting and talking and sharing information with the authorities and with collectively us as a community is by that just culture existing across all levels. And that's a key part, particularly, of the work we're doing. We have an EPAS safety promotion task, particularly around implementation of safety management and effective just culture. And it's equally, as I say, about that part of the relationship. So ultimately, what we're trying to do here is not just report occurrences because there's a rule that says we have to. What we really want to do is foster the spirit of community, where we're comfortable to share, to learn together, to develop safety promotion material together that we can all use to help this system grow, develop, and create and continue to evolve this amazing industry that's coming in this part of the industry. So that's my kind of setup. And as we were talking, I'd now like to introduce my two experts here, Lennart and Marta from the industry, who are going to give their perspectives on what this starts to look like from an industry viewpoint. And hopefully, this is just really starting a conversation about how we collect and share information. So, Marta, over to you. You have to point it.
Okay, so thank you. I hope that all of you are still awake and human on the room. Okay, so for sure, as I expected human, not only artificial intelligence, maybe on the room, remotely we have someone, but as you perform as human. So when something happens, like an incident, an event, or an accident, depend on us, for sure, we perform in different ways. So depend on our capabilities, in limitation, we interpret situation differently, and for sure we perform different, depend on our experience, or depend of how we are able to anticipate and maybe think about the possible outcome, no? And for sure, maybe we have as operator, as manufacturer, we have operational manual, we have procedure in place, but maybe there are situations that is so complex and we need to face up this problem and make a solution and make decision. And this happens when an incident happens, or maybe it's not there. I will explain later some situation. Or maybe we are influenced by others as community. As John said, we are a community, so we are influenced working with people. Also the technology, today, all of us are innovative air mobility, so that means this is new, it's complex, it's different, and the environment. So I want to ask you if you see, is there? Yeah. This situation, because for sure, half of the room probably are pilots. So you also use drone for fun, or maybe on remotely, they are listening some pilots. And what about this situation? If nobody look that you crash your drone. This is a very small drone, maybe 250 grams. And what about if this situation occur? You will act and behave in the same way? You just flip, look around you, or you will report? What about, maybe we are talking today about the US space implementation. This is one of the situations in Spain when they tried, and you are in a demo. So you are not the US operator, you are not the US service provider, and maybe something happened, and then you use the spoofing gun and said, okay, we will try to mitigate the risk. But what about, like I explained before, if something happened like that, it was not expected, and then you need to react, make a decision. It's very nice how they try to rescue the drone, because loss of control, because the spoofing gun failed, and maybe you are witness and said, I was not the US operator, I was not the pilot. Why I need to report this situation? Because it's possible. As citizen and as witness, why not? So reporting means sharing the risk. We can manage together. Okay. What about, because I expected also the room, I know that some of you are supply chain. I mean, you are providers from equipment. And the incident or accident or the event happened with your equipment, and you receive some reporting. And you said, maybe it wasn't a wind-fixed drone. Why I need to communicate to my other customer? Well, it doesn't matter. It's different drone, it's different equipment, it's why I need. Or what about if the parachute that is mitigation means fail? Or what about other safety critical equipment like ESCs, motor? Do you share with your supply chain what your supply chain did with this kind of information? Because again, reporting is two-way information sharing with you in both sides. And thank you, we don't need to forget that it's not only a small drone, it's also, in my case, like my company, eVTOL, during the type certificate phase, we are also, some of us, we are drone, big drone. So we cannot escape in this case. We cannot hide. It's so difficult. And I think that also report is to help others, to the industry, with the lesson learned, because we need to grow together. So, and don't forget that also in the vertiport, because also here in the room are for infrastructure, we also need to collect this kind of event that support to grow up the industry. And for sure, when something happened, maybe you think about, and maybe if you were a pilot that do and use your drone for fun, something is grown and you think about, and you need to chat with someone. No? As I said, all people is influenced by others, and said, this is typically, why do you want to complicate your life? Why do you need to report? Or maybe it was not your fault, but you think it about. Maybe someone, a hunter, decided to shoot your drone and said, oof, not, I don't want to complicate my life, because maybe the jazz give favor in the others, because it's maybe drone hater, but maybe we need to report, because there is some law that need to change. So this data is needed, because maybe we need more lovers. And what about if you are US operator or OEM, you are a manufacturer, or you are supply chain, you are suppliers, equipment manufacturer? Maybe I hope that maybe you have an SMS, you have a safety management, or at least some meeting, and you need to make a decision. Then we can have this kind of conversation. Maybe said, okay, the basic regulation is not mandatory to report, because I have no ATC, it's not certified category. Why I need to report? No, because it was no fatalities involved, no third parties damage. Why? Or maybe someone think if we report, our company reputation could be impacted, and maybe your competitor take advantage of that. Like why, as I put the example before, why this company needs to report, because really think that is important, the lesson learned. And then it's like, yes, but in my operational authorization said that this kind of thing is not needed. Anyway, just report, because it's important to share the lesson learned. And then how we do report? And then we go to the cars. Maybe some of you also said, okay, this is the right thing, I will go to report. And then we face that and another problems. If you are aviation expert, the taxonomy, where is the taxonomy for drones in a car? There are a lot of fields to fulfill that you have not the data. And maybe you struggle. And what about if you are like, I remember, I think it was from Azure Drone that said, or I think that also Wintra admin said, yes, but I have customers that are not from aviation. So, or I also are pilots that I want to report because I think that is the right thing. Do you think that they are capable to report by a cars? Is easy? It's not, believe me. Also for aviation expert, time to time, you struggle. And then in the room, I'm looking for some of the national authorities, EASA people, and then I want to challenge you. What kind of authority personnel are you when you receive this kind of report with bad news? Which kind of these two you can think about? When something happened, the US operator, the OEM, all the team are really motivated. You know, the mood is so bad, believe me. And then you go to the authority to tell that something wrong happened in your company or with your flight. And then you can face that. In my case, it's true that more in the left side than in the right, but I know some stories from industry members that they didn't have a lot of support. That maybe is good opportunity to all the ecosystem to learn together, so you could put your experience to support this new industry, because there are a lot of traditional aviation experience that could be used. Or maybe you said, oof, I have no resource, I have no training at all, what can I do? I have no resource to support them. Sorry, I need to be conservative. And just to finish, I would like to, this is Benidorm, is the first town in Spain that we will implement the US space, and I hope to see very soon this image. So this only is possible if all together here in the room and also remotely, we really believe in that. So together we need to do this possible, and for what we are doing these kind of things for. What are the benefits? First, because EASA and AA's industry will know the risk and they will assign resources. Therefore, operational authorization, may be granted early, because I listened to the rest of the 2 days that, oh, we have a lot of delays. The regulation for sure could be less restricted because we have more data, we have experience. So maybe, as John said, it's easy to make decision and maybe easy regulation, or maybe less demanding, And for sure, all together as a community, we will learn from each other, helping us to grow. And for sure, we are on the same aircraft, so I invited you to keep flying together on the same aircraft, because we are on the same aircraft and we want that this will be possible.
Thanks, Marta. Perfect. And now I'll hand over to Laurent from Jeddah.
Thank you. Hello, survivors. Save the best for last. Here I am, Laurent, from the board of Jeddah, and I want to show you when this works. It doesn't. Yes, it works. I want to show you the real workflow that's happening today whenever an incident occurs. An incident occurs, the first question is, has there been any damage? And when the question is no, then immediately we will say, we don't tell anyone. When there has been damage, then the second question is anybody aware that there was an incident? And when the answer is no, then we go back to, we don't tell anyone. And today, people actually report when they have no choice. That is, we have an incident, we have damage, and someone knows that there has been damage. And this is a big problem, because John and Marta explained why we need reporting. And together with Jeddah, we would like to change that. So there is a partnership between Jeddah and EASA. We want to change that. We want to make sure that every incident gets reported. And one of the most important things in the reporting of tomorrow is that the reporting needs to be easy. We have heard in the last 2 days the word simplification a lot, and it is necessary. We have to know that in the community of the drone pilots, of the drone operators, lots of operators are not from manned aviation. They don't know the terms that are used. They don't know what we are doing in manned aviation, yet we are sharing the same space. So we need easy reporting systems. We need things that are mobile phone friendly. Lots of you are on their mobile phones at the moment, and the pilot on the train also has a mobile phone with him or her. So we need to have things that allow an immediate reporting. We also need to think about the terminology. Like Marta said, when you are on the official reporting platform, half of what you see you don't understand as a basic drone pilot, if I may use this word, basic. So we also need to think about the terminology. We need to think about how can we make that easy. It's also important that not only big accidents need to be reported, but also small incidents that are non-fatal, that are not involving manned aircraft. It's no manned aircraft involved. And also for very low risk flights, so also in the open category, we need to report a small incident, because possibly a small incident is actually an accident waiting to happen. And I would even go further. We also need to have numbers about flights without any incident. If there are 2,000 aircraft that are crashing and we don't know how many flights are done, well, is it 2,000 out of 2,000? Then it's a big problem. Is it 2,000 out of 2 million? Then it still remains a problem, but it's a smaller problem. So we also need to know how many flights are actually happening. We have said in the last days that we need simplification, that the rules are sometimes too complicated, but in order to lower the level, we need to make sure that the risk is also lower. And without a good data, well, we don't know that. So the only way to have a positive impact on the regulation, and I mean less regulation, is to be able to prove that the operation is actually safe. And we can only do that by reporting. So we need to collect data, we need to aggregate the data, we need to have a very heavy promotion campaign. People need to know what Just Culture is. We don't need to be afraid of reporting, and we definitely need a clean picture. So for the last slide of today, I would like to show you the real holiday picture of John. Thank you.
Thanks to both. And yeah, hopefully maybe you guessed it beforehand, but gave you something to think about. Huge thanks to Marta and Laurent there for just giving their insights and starting that discussion as it was always intended as a starting point for hopefully a longer term discussion with the community. I don't know, do we have maybe one question we got time for, or maybe we take one and then maybe we won't have any. Oh, I saw one there. How is the taxonomy for RPAS evolving? It is continually evolving. I know there's lots of discussion between the different parts of the industry. I know you've been involved in some of that already. Maybe you want to answer what you've been doing, Jeddah?
Yes, well, at the moment not, but it's definitely planned to modify, as I mentioned, to have a simplified reporting system, and it will also go with a simplified taxonomy. Lots of things are not really relevant for drone operations. So it's an ongoing work, but it's definitely going to happen.
And then in terms of that last one, what about reporting something being destroyed perhaps during test flights? Certainly as somebody who used to lead the safety analysis team here, every piece of information we get helps with the analysis to help the risk management activity and help answer questions that our technical experts have, whether that's on making future rules. Now in safety promotion, if there's a particular risk that led to something happening that others can know about to help this industry grow, then yeah, the more we get, the better from my perspective. So yeah, certainly that's what I would say. Okay, well, thanks very much for your time. I'm pleased that you stayed. It's great to have you all. And I'm going to hand over to our certification director, or Maria, are you going to take the next bit?
Thank you very much, John.
Thanks, Will.
So our journey goes to an end, and in order to make the conclusions remark, so Rached Desalat, the certification director, we give them.
Thank you, Maria, and thank you very much to the previous panel. I think it's a very remarkable that we finish with a panel entirely dedicated to safety. We have learned and listened about many topics over these 2 days. Today was a lot about automation, about airspace integration. And the last panel on safety, I think, reminds us that safety is a prerequisite to develop this innovative air mobility new aviation sector. I think we have managed so far to do well in terms of safety performance for drone operations, but we need to be very vigilant and keep a close eye, because we start with the increase of operations volumes, we start to see accidents and incidents. We start to see also some injuries, nothing dramatic, but it's something that happens and that has the potential to become worse if we don't pay close attention. And the reporting culture and all the things we need to do in terms of facilitating the reporting, analyzing the data is important. We have a conventional aviation sector which has been improving its safety performance over decades, largely because of all the lessons learned from accidents, but also a lot from all the incidents that were analyzed and thoroughly addressed. So I think this is also something we have to do for drones. It is very much linked to simplification of rules, which was a big topic yesterday. I think we have very well heard the message that the rules are complex, that we need to do something to help you more, to ease a little bit the administrative burden. This goes hand in hand with carefully looking at the safety performance of the sector. So, time to conclude really this two-day workshop. It's the first time we are having this kind of event on innovative air mobility in-house at EASA location. It has been challenging, and I would like to apologize for any logistics related inconvenience that you had because of the organization of the catering or because of the room. We are constrained obviously by the place we have. The advantage of that is that we can limit, obviously, the costs associated to organizing such an event. As part of the follow-up actions, we will circulate a survey. Please help us organizing the next event that we will have maybe next year, or we will need to calibrate the format in terms of content, in terms of duration, in terms of location. So thank you in advance for contributing to that. We will also make available the presentations and the recordings. I think we have also to work on a kind of summary conclusions and try to summarize all the main takeaways for EASA in particular and the NAAs on all the various topics that were discussed that should lead at some point in time, depending on priorities, on either work at the level of the rules, at the level of guidance, or something else, such as working on the occurrence reporting framework for drones. So I think this will be also a very useful part of the conclusion of this two-day event, to try to put in a single document the main, I would say, the main areas of further actions on the authority side. And finally, I would like to thank very warmly all the speakers, especially the industry speakers that I found very open in sharing a lot of what is happening in their own organization. So that's not necessarily granted in other parts of the aviation world. I really found the industry to be ready to share a lot, and I think it's for the benefit of everybody. And last but not least, I would like to thank the EASA team involved in organizing this event, and I would like them to stand up, everybody who contributed on the EASA side to preparing, to speak, etc. And that's it for today. So I wish you safe trips back home, and thank you very much for your time and energy during these 2 days. Thanks.